The universe is both impossibly vast and impossibly precise. Within the first heartbeat after the Big Bang, invisible forces arrange themselves with such delicate exactness that galaxies, stars, and even you could exist. Imagine standing at the edge of a dark sea, where four silent tides pull and push, so subtle you cannot see them, yet so absolute they keep everything from falling apart. Tonight we will drift along those tides, gravity's patient embrace, the electric spark that sculpts atoms, the fierce glue inside every nucleus, and the quiet alchemy that changes one particle into another. As we breathe, we'll feel how these forces weave the cosmos, and ask a gentle question: why this balance, and what does it mean for us? Like and subscribe if this sounds like a story you want whispered through the night, and join us on this slow starlit journey. Let's begin. Everything in existence, every atom, every galaxy, every breath you take, is balanced on four invisible forces: gravity, electromagnetism, and the two nuclear forces weave together a cosmic web so precise that if any were slightly weaker, the universe would unravel into nothing. These four forces are the quiet architects of reality. You cannot see them, but you can feel their touch in everything, from the pull of your feet to the ground, to the warmth of sunlight on your skin, to the stability of the atoms that make up your body. They are the threads that tie space to time, matter to energy, and existence to possibility. Together, they form the delicate scaffolding that keeps the cosmos intact, a balance so perfect that it borders on the miraculous. Imagine the universe as an immense tapestry, woven from the light of creation itself. The galaxies are patterns, the stars are knots of brilliance, and between them runs the invisible stitching of the four forces. Gravity pulls the threads tight, giving the tapestry its shape. Electromagnetism colors it with light, energy, and motion. The strong nuclear force binds the smallest pieces together, while the weak force allows transformation, the silent rhythm that lets stars burn, atoms change, and time flow forward. Without these forces, there would be no shape, no color, no life. If gravity was slightly stronger, the universe would have collapsed in on itself moments after it began. If it were weaker, matter would never have clumped together at all, and space would be nothing but an endless frozen fog of particles too far apart to form stars. If electromagnetism changed even by a fraction, atoms could not hold their electrons, and nothing solid would ever exist. The strong nuclear force, so powerful it binds the hearts of atoms together, must be exact. A small variation, and the protons inside every atom would fly apart. And the weak force, that subtle hand that turns one particle into another, must also be tuned precisely, or stars would never shine. Every law of physics, every constant of nature, is fine-tuned, as though the universe itself was written in a perfect language. And yet, there is no author, only balance. It's as if nature discovered a way to write harmony into chaos. From the smallest atom to the largest galaxy, every layer of existence depends on the flawless interplay of these four forces. When we look up at the night sky, we are not just seeing stars, we are seeing the mathematics of perfection. Each beam of starlight that reaches your eyes is a message from the universe saying, "I am still holding together." The space between those stars is not empty, it hums with tension, with invisible threads connecting every point to every other, like the fabric of a great cosmic web stretched across infinity. You are part of that web. Every atom in your body is bound by the same laws that hold distant galaxies in orbit. The calcium in your bones was forged by the strong nuclear force in a dying star. The iron in your blood was once part of a cosmic explosion that released light through electromagnetic waves. Even the gentle pull of gravity that anchors you to the Earth connects you to everything else that exists. The universe does not simply exist, it is held. Every second, the four forces whisper across the void, maintaining balance. You are the result of their conversation, a fleeting but perfect arrangement of matter, shaped by harmony older than time. In their dance, chaos finds form, and silence gives birth to everything that has ever been. And perhaps, if you listen closely, beneath the hum of atoms and the quiet of space, you can almost hear it, the soft tension of the fabric that holds it all. In the beginning, there was only energy, raw, directionless, infinite. Then, as the universe cooled, that energy split into 4 distinct powers. It was in this symmetry breaking that structure itself was born. Before time had meaning, before light had direction, the universe was a singular moment, a sea of pure potential. Every particle, every star, every law of physics that would ever exist was contained in that first instant, compressed into a point smaller than a grain of sand. There was no space, no matter, no separation, only unity. And then, in less than a trillionth of a second, everything changed. That change is known as symmetry breaking, the moment when the perfect balance of the early universe fractured, giving birth to difference. It was not destruction, but creation through imbalance. In that instant, the uniform field of energy diversified into 4 distinct personalities: gravity, electromagnetism, the strong force, and the weak force. Each took on a unique role, shaping how matter, energy, and time would behave forever after. Imagine a calm pond suddenly disturbed by a single drop of rain. Ripples spread outward, patterns emerge, and the stillness transforms into motion. The universe began in much the same way. In its earliest moments, it was perfectly symmetrical, every direction identical, every particle indistinguishable. But perfect symmetry is fragile. It cannot last. As the universe expanded and cooled, imperfections formed, tiny fluctuations in the sea of energy. Those imperfections were the seeds of everything to come. Gravity became the quiet architect, gathering matter into galaxies and stars. Electromagnetism became the artist, painting light and shaping atoms. The strong force became the builder, binding the atomic hearts that would one day form planets. And the weak force became the catalyst of change, governing transformation and decay, the silent ticking of cosmic time. From that first imbalance, chaos became order. It's strange to think that the universe we know, stable, structured, beautiful, was born from imperfection. But it's precisely that imperfection that allowed matter to exist at all. If symmetry had remained perfect, every particle would have met its twin in annihilation, leaving only energy. There would be no galaxies, no stars, no life, only light fading into infinity. So, the universe tilted ever so slightly off balance. Matter began to outweigh antimatter by a fraction, just enough for something to remain after the Great Annihilation. For every billion particles of matter and antimatter that collided and vanished, one was left behind. You are made of those survivors, the cosmic leftovers of that ancient asymmetry. That tiny bias became the foundation of everything. Out of instability came structure. Out of imbalance came beauty. The forces that emerged began to compete and cooperate, shaping the destiny of space and time. They governed how energy condensed into atoms, how atoms joined into stars, and how stars forged the elements of life. Every atom in your body carries the memory of that moment. The carbon in your cells, the oxygen you breathe, the light that fills your eyes, all trace back to the instant the universe chose complexity over perfection. The moment of balance wasn't calm, it was creative chaos, a storm of becoming. Yet from that storm came harmony so exact that billions of years later, the cosmos still holds together. The 4 forces, born from one, continue their silent collaboration, sustaining the structure that began with a single, elegant fracture in symmetry. And so, every star, every breath, every flicker of existence is a ripple from that first cosmic disturbance. The universe was not built by stability, it was sculpted by the art of imbalance. Gravity is the universe's slowest whisper, yet its reach is infinite. It pulls dust into stars, stars into galaxies, and galaxies into clusters, a gentle sculptor shaping the grand cathedral of space. It is the first and oldest of the cosmic forces, born in the earliest heartbeat of the universe. Gravity does not rush, it waits. While the other forces dance on atomic scales and flicker through quantum realms, gravity moves with the patience of eternity. It speaks in curves and bends, not in collisions. It does not push, it invites. Imagine the universe just after its birth, an ocean of gas and energy expanding in every direction. Within that chaos, tiny ripples of density began to form, small pockets where matter clumped a little more tightly than in others. These were gravity's first brushstrokes. Over billions of years, those ripples grew into galaxies, nebulae, planets, and everything we know. The cosmic web itself, the immense network of filaments connecting clusters of galaxies, is gravity's grand design, an invisible architecture spanning the whole of space. On the smallest scales, you barely feel it. It tugs softly on a falling leaf, bends the flight of a bird, pulls the tides against the shore. But on the largest scales, gravity is the ruler of all things. It binds galaxies together into massive clusters, holds stars in their orbits, and gives shape to time itself. Every orbit, every fall, every spiral across the heavens is the signature of gravity's hand. Einstein once described it not as a force, but as the curvature of space-time, a bending of reality itself. Mass tells space how to curve, and space tells matter how to move. It's an elegant feedback loop, a cosmic conversation between presence and motion. The Earth doesn't so much pull the moon as it creates a valley in space-time that the moon perpetually falls into, never touching the bottom. If you could see gravity, it would look like the slow breathing of the cosmos, waves rippling outward from every massive object, invisible and eternal. When two black holes collide, they send gravitational waves through the fabric of reality itself. Tiny shivers that pass through your body unnoticed, yet stretch and squeeze space-time as they go. Those ripples are echoes of creation, reminders that even the emptiest darkness is alive with motion. But gravity is not merely a builder, it is also a destroyer. The same pull that births stars also dooms them. It compresses their cores until nuclear fires ignite, and when those fires die, gravity crushes what remains. Some stars collapse into white dwarfs, others into neutron stars, and the most massive into black holes, where gravity becomes so strong that not even light can escape. And yet, without gravity's relentless patience, there would be no stars at all, no warmth, no light, no chance for life. It is the sculptor of possibility, drawing the universe together from chaos and holding it there against the urge to scatter. Every time you stand beneath the night sky, you are standing in the quiet heart of gravity's design. The ground beneath you, the moon above you, the distant stars twinkling through the dark, all are locked in its embrace. You are part of that same dance, tethered to the Earth, which is tethered to the Sun, which circles the center of the galaxy, a cosmic choreography written by gravity's invisible hand. It does not hurry. It does not sleep. It simply endures, shaping the universe one moment at a time. And though it may seem the most silent of the four forces, gravity is the reason there is a stage for existence at all, the unseen architect building eternity from the quiet pull of forever, from the swirl of distant galaxies to the pull that keeps your feet on Earth. Gravity is not a force you see, but one you feel in every step. It binds the cosmos with a patience beyond time. Every movement in the universe, every fall, every orbit, every slow spiral of galaxies drifting through the void is part of gravity's endless choreography. It is the quiet rhythm behind all motion, the invisible partner that guides every cosmic waltz. Long before there were stars, before planets spun or moons shimmered, gravity began this dance. Out of chaos and expansion, it found a way to gather, to hold, to shape. Picture the early universe as a vast mist of hydrogen, light and directionless. Within that mist, small ripples of matter began to coalesce, drawn together by the gentlest of tugs. Over millions of years, those tiny ripples became stars, balls of fire burning against the darkness. Then, with time, stars began to circle one another, their orbits carved by gravity's grace. Around them, planets formed, drawn into the rhythm like dancers joining a spiral. Even now, billions of years later, the galaxies themselves continue to spin, moving to the same silent beat. You feel it too, though you may not think about it. Every step you take, every leap and return, is gravity's conversation with you. The Earth pulls you gently downward while you push back with equal force. That balance, so ordinary, so constant, is the same principle that keeps the moon from falling into the Earth and the Earth from falling into the sun. Every orbit is just a controlled fall, forever in motion, yet never colliding. There is poetry in that, the balance between surrender and resistance. Gravity is not domination, it is partnership. The planets do not fight their orbits, they flow with them. The stars do not resist their clusters, they harmonize. Even black holes, those dark hearts of collapsed stars, do not end the dance, they simply change the tempo, bending space and time into new rhythms, drawing light itself into their steps. On the grandest scales, gravity sculpts beauty from emptiness. It spins galaxies into spirals, stretches filaments of stars across millions of light years, and arranges the cosmic web like a frozen motion of light and shadow. What looks like stillness to us is a vast and graceful ballet, everything in motion, everything falling together in perfect order. And yet, gravity is the most patient artist. It takes billions of years to build its masterpieces. Stars live and die under its direction, galaxies merge and drift apart, and through it all, the universe never stops moving. The dance never ends, it only changes form. You are part of that movement. Every atom in your body is held together by forces born in that same cosmic choreography. When you jump, when you breathe, when you sleep, you are dancing too, held in the same rhythm that guides planets and comets and the stars themselves. Gravity is the thread that keeps everything connected. It doesn't need to shout or burn or crash to be heard. Its music is subtle, woven through the quiet hum of existence. From the swirl of galaxies to the pull beneath your feet, every motion in the cosmos moves to its beat. And so, the universe continues its eternal waltz, every orbit, every spin, every heartbeat a step in the dance of attraction, choreographed by the most patient partner of all. While gravity builds the vast architecture, electromagnetism animates it. It paints the glow of nebulae, powers the lightning on alien worlds, and lets atoms hold hands to become matter itself. If gravity is the sculptor of the cosmos, then electromagnetism is its artist, the force of color, light, and connection. It dances at every scale of existence, from the swirling clouds of charged gas that fill galaxies to the flicker of neurons firing inside your brain. It is the thread that ties the universe together, through weight and pull, but through energy and light. Every spark you've ever seen, every beam of sunlight that has ever touched your skin, every flash of lightning that's ever cracked the sky, all are moments when electromagnetism reveals itself. It is the reason atoms stay bound, why molecules form, why light travels through space to bring warmth and sight to living worlds. Without it, there would be no chemistry, no color, no sound, no life. At its heart, electromagnetism is a conversation between charged particles, between the positive and the negative, the proton and the electron. Their attraction and repulsion form the foundation of matter's stability. This constant tension is not chaos but harmony, a relationship that allows atoms to exist as tiny universes of balance. When you look at a nebula glowing in the depths of space, what you're really seeing is charged gas, plasma, excited by electromagnetic fields. Those glowing colors, pinks and blues and golds stretched across light years, are the language of electromagnetism written on the canvas of the cosmos. Stars themselves are powered by it, immense fusion furnaces where charged particles collide, generating light that crosses the void to tell their story. On Earth, electromagnetism is all around you, woven into the very act of being alive. Every heartbeat is an electrical impulse. Every thought, every memory, is a ripple of electromagnetic energy moving through the delicate wiring of your nervous system. The rhythm of your existence is electric, echoing the same principles that shape the auroras at the poles and the storms on Jupiter's surface. Yet, electromagnetism is not merely energy, it is order. It gives form to chaos by dictating how particles interact. It defines the structure of atoms, creates the bonds of molecules, and determines how light behaves as both wave and particle. It is one of nature's most paradoxical gifts, invisible, yet it defines everything we see. If gravity connects the cosmos through its pull, electromagnetism connects it through its conversation. Every atom is surrounded by its own electric field, interacting with those around it in a silent dance of attraction and repulsion. This constant interplay forms the invisible latticework that holds all matter together, from the smallest grain of dust to the largest star. And through this invisible tension, light is born. A photon, the purest expression of electromagnetism, is the universe's messenger. It carries energy across unimaginable distances, telling the story of galaxies that died before Earth even formed. Every glimmer in the night sky, every spark that leaps from wire to wire, is a photon fulfilling its ancient purpose: to move, to illuminate, to connect. Electromagnetism is the living pulse of the universe. It hums through every atom, hums through you, shaping both matter and meaning. Gravity gives the universe its stage, but it is electromagnetism that turns on the lights, raises the curtain, and begins the show. Without it, the cosmos would be silent and dark, a sculpture without color, a body without breath. But because of it, the universe glows. Every star, every aurora, every heartbeat is proof of the same electric thread running through everything, binding us all in light. Without electromagnetism, electrons would drift aimlessly, unable to orbit their nuclei. The world would be transparent, nothing solid, nothing real, only a haze of lost particles floating in silence. It's easy to forget how fragile the concept of solid truly is. The chair beneath you, the air you breathe, the ground beneath your feet, all of it exists because of invisible electrical attraction. Every atom in your body is a delicate solar system, with electrons endlessly circling a tiny core of protons and neutrons. What holds those electrons in place, what gives the illusion of matter stability, is electromagnetism. Picture an electron and a proton, opposites in charge, endlessly drawn to each other, yet never touching. Their dance creates the simplest atom, hydrogen. Multiply that bond billions of times, and you have everything from stars to oceans to you. Every molecule, every element, every chemical reaction depends on this quiet, magnetic romance between charged particles. Electromagnetism gives matter its boundaries. It defines how close two atoms can come before they push away, how they lock together to form molecules, how those molecules link into the structures that make up everything we know. Without it, atoms would not recognize one another. They would pass through each other like ghosts, leaving the universe a transparent storm of unbound energy. In a way, electromagnetism is the architect of texture. When you touch something, a stone, a leaf, another person, you never truly make contact with the material itself. What you feel is the electromagnetic resistance between your atoms and theirs. The pressure you sense, the warmth you exchange, the very concept of touch, is the language of charged particles interacting in the invisible space between them. This force doesn't just shape the physical, it defines the visual. The colors you see are born from the way electrons absorb and release energy. When light strikes an object, it excites the electrons within its atoms. Some of that energy is re-emitted as new light, while the rest is absorbed. The difference between absorption and reflection is what creates color. The blue of an ocean, the green of a leaf, the crimson glow of a sunset, all are signatures of electrons responding to light, painting the world in electromagnetic hues. But perhaps electromagnetism's greatest masterpiece lies in its consistency. Across the vastness of the cosmos, it behaves the same everywhere. From the smallest atom in your hand to the plasma storms raging on the surface of distant stars, the same laws apply. It is the quiet sculptor that never forgets its craft, ensuring that structure and pattern persist no matter where you look. Even the chemistry of life itself depends on this force. DNA's spiral, water's polarity, the way oxygen binds to hemoglobin, all are consequences of electromagnetic behavior at the atomic scale. It doesn't just allow life to exist, it designs life's blueprint with mathematical elegance. And yet, for all its importance, electromagnetism remains humble. You can't see it directly, only its art, the colours, the textures, the sensations it creates. It works unseen, holding the universe in place with infinite precision, balancing attraction and repulsion in equal measure. So the next time you reach out and touch the world, remember, you are feeling the shape of invisible forces. Every solid surface, every heartbeat, every spark of light is an expression of electromagnetism's unseen craft. It is the hidden sculptor of atoms, the force that turns emptiness into form and chaos into something you can hold. Deep inside the heart of every atom lies the strongest of all forces, one so powerful that it binds protons together against their mutual repulsion. The strong nuclear force is the most intense connection in the universe. It operates over distances so small that they defy imagination, yet it carries the strength to hold the fabric of reality together. Within the nucleus of every atom, protons, each carrying a positive charge, should violently repel one another, scattering apart like magnets forced too close. Something stronger holds them fast, an invisible bond born in the earliest moments of creation. It is often said that gravity builds the cosmos, and electromagnetism brings it to life. But the strong force is what allows those larger stories to exist at all. It's the foundation beneath everything, the hidden cement of existence. Without it, atoms could not form, stars could not burn, and the universe would be a cold fog of unbound particles adrift in endless emptiness. To understand it, we must travel into the atom's core, beyond the electrons, past the orbiting shells, into the nucleus itself. Here, the protons and neutrons are bound together by a storm of subatomic energy. The strong force acts through particles called gluons, named for their ability to glue other particles together. These gluons constantly exchange between protons and neutrons, binding them so tightly that separating them requires more energy than any known explosion could provide. It is a force that resists loneliness. When scientists try to pull quarks, the building blocks of protons and neutrons, apart, the strong force doesn't weaken. It strengthens. The farther they stretch, the more fiercely they pull back, until eventually new particles burst into existence rather than allow separation. In this way, the strong force ensures that quarks are never alone. It enforces unity at the most fundamental level of matter. This is not just power, it's persistence. The strong force doesn't reach across galaxies like gravity, nor does it dance in visible light like electromagnetism. Its realm is one of confinement, of intimacy. It acts only within the tiniest of distances, less than the width of a single proton, and yet within that scale, it is 39 orders of magnitude stronger than gravity. It is the engine of the stars. Inside stellar cores, where temperatures soar to millions of degrees, protons overcome their mutual repulsion just long enough for the strong force to take over, fusing them together. This fusion releases unimaginable amounts of energy, light, heat, radiation, that travel across the cosmos and reach our world as sunlight. Every sunrise, every flicker of flame, is powered by the strong force working at the smallest scale imaginable. And in death, it gives again. When massive stars collapse, the strong force resists until it can no longer bear the weight. Then, in a single instant, it yields, exploding outward in a supernova that forges new elements, seeding the galaxy with the raw ingredients for life. The calcium in your bones, the iron in your blood, the gold in your jewelry, all were created in those moments when the strong force both held and released. It is, perhaps, the most poetic of all the cosmic forces, the one that teaches us that strength lies in connection, that unity can overcome repulsion, that even in the smallest spaces, the will to hold together can shape an entire universe. So when you look at the world around you, the solidity of the ground, the warmth of the sun, beneath every surface, every element, every heartbeat, the strong force is working tirelessly, unseen and unstoppable, holding the universe together from the inside out. It is the core of existence, the silent strength that refuses to let go. This force operates on scales smaller than imagination, distances so short that 1 billion of them fit inside a single atom. It is the reason stars can ignite and why you exist at all. The strong nuclear force is the most intimate and mysterious of all the universe's interactions. It works within the tiniest spaces known to science, so small that no microscope could ever see it directly. Yet, in these minuscule distances, it performs the most essential act in the cosmos, holding the heart of every atom together. Without this invisible glue, the world would dissolve into a mist of unbound particles, unable to form stars, planets, or life. To understand its power, we must journey inward, deep into the nucleus, where the very building blocks of matter reside. Inside, protons and neutrons huddle tightly together, packed so closely that they seem on the verge of collapse. Each proton carries a positive electric charge, and by all logic, they should repel one another violently. And yet, they don't. Something stronger intervenes. That something is the strong nuclear force. It acts through particles called gluons, exchanged constantly between quarks, the tiny, vibrating entities that make up protons and neutrons. These gluons are relentless, forming an unbreakable connection that grows stronger as you try to pull it apart. The more you separate the particles, the greater the force that draws them back together. It's a bond that refuses distance, a connection so profound that it defines the very meaning of cohesion. This strange behavior is what gives the strong force its paradoxical name. Unlike gravity, which weakens with distance, or electromagnetism, which fades as charges move apart, the strong force grows stronger the more it's stretched. It is nature's way of enforcing closeness, ensuring that nothing at the smallest scales can exist in isolation. In stars, this force becomes the foundation of fire. Inside their blazing cores, the strong force ignites the process of nuclear fusion, pressing hydrogen nuclei so close that they overcome their repulsion and merge. When they do, a fraction of their mass transforms into pure energy, released as light and heat. Every ray of sunshine that warms your face is powered by this ancient bond, the strong force converting matter into radiance across billions of years. But the strong force's work doesn't end there. When massive stars die, it plays another role: resistance. As gravity tries to crush the star into oblivion, the strong force holds out until the last possible instant. Then, when it finally yields, the collapse triggers an explosion so powerful it forges new elements: carbon, oxygen, gold, and iron, the very materials that make up planets and living beings. It is both the maker and the destroyer, the reason matter endures and the reason it transforms. The strong force is the ultimate expression of balance, a relentless urge to bind, countered by the energy it releases when that binding breaks. Every heartbeat, every atom, every star owes its existence to this cycle of holding and letting go. If you could see it, the interior of an atom would not look still. It would be alive with motion. Quarks spinning, gluons flickering, energy pulsing through the tiny nucleus like a miniature storm. It's not a static structure, but a living sea of interaction, forever shifting, forever held together by the strongest embrace in the universe. The glue of the nucleus is invisible, yet everything you can touch, see, and feel is its creation. It keeps the stars burning, the elements stable, and the universe coherent. Without it, there would be no light, no structure, no life, and yet it asks for nothing in return. It simply holds, quietly, endlessly, keeping existence itself from falling apart. It may sound fragile, but the weak nuclear force is nature's quiet transmuter. It turns one kind of particle into another, transforming hydrogen into helium, light into life. While gravity shapes the vast architecture of galaxies and the strong force binds the atomic heart, the weak nuclear force works in the shadows, whispering its influence where transformation is needed most. It is the universe's alchemist, changing the very identity of matter itself. Without it, stars would never shine, elements would never form, and life would never begin. The weak force lives up to its name in strength but not in significance. It acts only over subatomic distances and operates far less powerfully than the strong force or electromagnetism. Yet its impact is monumental. Its gift is change. Where the other forces preserve and stabilize, the weak force transforms. It governs decay, turning neutrons into protons, protons into neutrons, and releasing neutrinos, those ghostly particles that pass through your body by the trillions every second, unnoticed and unharmed. This process, called beta decay, may seem obscure, but it is the hidden engine of the cosmos. It is what allows hydrogen, the simplest element, to fuse into helium in the hearts of stars. Each time this happens, a small portion of matter transforms into energy, bursting outward as starlight. The glow of the night sky, the warmth of the sun on your skin, the very concept of light as we know it, all are gifts of the weak force in action. In the early universe, the weak force played an even greater role. A fraction of a second after the Big Bang, it determined the balance between protons and neutrons, setting the stage for all matter that would ever exist. Had its strength been slightly different, the ratio of elements in the universe would have changed completely. There might have been too much hydrogen and no heavier elements, or too much helium and no stars. The chemistry of life depends on the delicate tuning of this subtle, invisible hand. But the weak force does more than sustain the stars. It connects the visible world to the invisible. Through neutrinos, it ties every piece of matter to the fabric of creation itself. These ghostly travelers carry information from the hearts of stars, from supernova explosions, even from the dawn of time. They are the messengers of the weak force, silent witnesses to the evolution of the cosmos. And though it operates beyond our senses, its fingerprints are everywhere. The carbon in your body, the oxygen you breathe, the calcium in your bones, all were forged through processes that depended on the weak force's quiet alchemy. Every element heavier than hydrogen owes its existence to a chain of transformations it set in motion billions of years ago. If the strong force is the glue that holds the universe together, then the weak force is the breath that lets it evolve. It allows matter to change form, to decay and renew, to fuel the continuous rebirth that defines the cosmos. Without decay, there would be no energy, no cycles, no motion, just stillness. The weak force gives time its direction. In its silence, there is wisdom. The weak force reminds us that strength is not always loud, nor power always visible. Some of the most profound changes in the universe happen quietly, atom by atom, unseen but unstoppable. So when you look up at the stars and see their light crossing the vastness of space, remember that light was born from weakness. The most delicate of the four forces forged the brilliance of the cosmos, turning simple hydrogen into the fire of creation. The weak force is the universe's softest whisper, and its most enduring act of transformation. Inside stars, the weak force governs decay, transformation, and birth. It is what makes the sun shine, an endless chain reaction of atomic metamorphosis lighting our days. Every sunrise is a memory of creation repeating itself. Deep within the sun's blazing core, At temperatures beyond comprehension, trillions of hydrogen atoms collide every second. They fuse, they transform, they become something new, and in that act, light is born. At the heart of that transformation lies the weak force, orchestrating the most important reaction in the universe, turning matter into energy. It's a process so delicate, yet so consistent, that it has powered the cosmos for billions of years. When two protons meet inside the sun, they should repel each other. Both are positively charged, and the electromagnetic force between them is immense. But occasionally, against all odds, quantum chance allows them to get close enough for the weak force to intervene. One proton transforms into a neutron, releasing a positron and a neutrino. In that instant, hydrogen becomes deuterium, a heavier form of itself, and the chain of fusion begins. This is the spark of creation, repeated countless times every second across the stars. Each act of fusion releases light, heat, and radiation that stream outward into space. It takes thousands of years for that energy to rise from the sun's core to its surface. But once free, it crosses the 93 million miles to Earth in just over 8 minutes. Every ray that touches your skin, every glimmer on the ocean, every shadow that falls across the ground, that is ancient energy from the weak force's transformation, reaching you across time. The same process happens in every star you see in the night sky. Some are small, burning slowly and steadily. Others are massive, fusing elements at a furious pace until they die in spectacular explosions. But all of them, every single one, shine because the weak force allows them to. It is the bridge between particles, the translator that turns raw mass into radiant energy. And in their deaths, the stars continue to create. When their nuclear fuel runs out, gravity crushes them inward until they collapse, triggering bursts of fusion that forge new elements. Carbon, oxygen, iron, all born from this cycle of transformation. In the violent last moments of a star's life, the weak force once again takes command, turning protons into neutrons and releasing floods of neutrinos that carry away the dying star's final breath. Those neutrinos travel through everything: planets, people, even lead walls, almost without interaction. They are the silent witnesses of cosmic birth and death, passing through your body by the trillions every second, carrying messages from ancient stellar furnaces light years away. They remind us that the universe is always in motion, always changing, always alive with transformation. What the weak force teaches us is that destruction and creation are not opposites, they are partners. Every decay gives rise to new order, every transformation births light. The same process that fuels the sun also built the atoms of your body, passing its energy down through time until it found form in you. When you stand beneath the sunlight, you are bathed in the echoes of that endless process, the quiet alchemy that began before Earth existed and will continue long after it's gone. The weak force is not merely the cause of light, it is the light, the mechanism by which the universe turns possibility into being. In the glow of every dawn, you are witnessing the spark of creation itself, the timeless pulse of transformation that began with the first stars and will one day give birth to the last. These four forces are not rivals. They are a symphony, each playing a different instrument, yet together composing the song of existence. For all their differences, gravity, electromagnetism, and the strong and weak nuclear forces do not work in isolation. Each has its own domain, its own rhythm, its own tempo, but it is their harmony that creates the universe we know. Like the movements of a cosmic orchestra, their interactions shape everything from the tiniest quark to the grandest galaxy cluster. Alone, they are remarkable. Together, they are creation itself. Imagine the universe as a grand composition, one that began with the faintest note of the Big Bang. Gravity sets the baseline, deep and slow, giving the cosmos its structure and weight. It draws the instruments together, binding them into patterns that endure. Electromagnetism provides the melody, bright and vivid, giving light, chemistry, and energy their form. The strong force adds the rhythm, pulsing at the atomic core, ensuring that matter holds its shape. And the weak force introduces variation, a subtle improvisation that allows elements to change, to evolve, to become something new. If even one of these instruments fell silent, the song would end. Without gravity, galaxies could not coalesce. Without electromagnetism, atoms would drift apart. Without the strong force, nuclei would collapse. Without the weak, stars would never shine. It is not one force that sustains the cosmos. It is all four, woven into a single, unbroken harmony. You can feel their unity in every breath you take. The air you inhale is drawn down by gravity, bound by electromagnetic forces, composed of atoms held by the strong force, and forged long ago in stellar furnaces powered by the weak. The act of breathing itself, so ordinary, so human, is the expression of cosmic cooperation. Science describes this interplay in equations and constants, but beneath the mathematics lies poetry. The four forces are the universe's way of maintaining conversation with itself. They balance, respond, and adapt, ensuring that no single force dominates. Gravity gathers, electromagnetism connects, the strong binds, and the weak renews. Together, they make possible a reality that is both stable and dynamic, a universe that can endure and yet still change. Physicists have long sought to unite these four into a single law, a theory of everything. They believe that, in the beginning, all forces were one, different notes in a single chord. As the universe expanded and cooled, the harmony split into its present form, each force taking on its own identity. But perhaps, on some deeper level, they are still one, still bound by the same cosmic unity that birthed them. When you look up at the stars, you are witnessing the universe's composition in motion. Gravity holds the galaxies together. Electromagnetism sends their light racing toward you. The strong and weak forces shape the atoms within those stars. What you see is not chaos, but choreography. A dance so intricate, it gives rise to order, beauty, and life. The four forces are not separate stories. They are four chapters in the same song, endlessly replayed across the fabric of space and time. Every photon that shines, every atom that forms, every galaxy that turns is part of their eternal harmony. And as that harmony continues, we, too, become part of the melody. The forces that shape the cosmos also shape us. The song of the universe plays within every heartbeat. If gravity were just slightly stronger, stars would collapse. If electromagnetism weaker, atoms would fall apart. The universe exists in an impossibly narrow balance between chaos and collapse. Everything you see, every mountain, every cloud, every spark of light, depends on the fine-tuning of forces so precise that even the smallest deviation would unravel reality. The universe, for all its vastness, walks a razor's edge between existence and oblivion. This fragile equilibrium is not an accident of chance. It is the quiet miracle written into the laws of physics, a balance so exact it defies intuition. Imagine adjusting a single dial, one that controls the strength of gravity. A tiny increase, and the cosmos would have ended almost as soon as it began. Stars would burn too hot, collapsing under their own weight before planets could ever form. A tiny decrease, and matter would never have gathered at all. The universe would be an endless sea of dust and gas, too diffuse to ignite, too weak to shine. Electromagnetism, too, must be tuned with infinite care. If its pull were slightly weaker, electrons would fly free from their atoms, leaving nothing solid, no air, no water, no living world. If it were slightly stronger, electrons would cling too tightly, preventing chemical bonds from forming, silencing the diversity of molecules that make life possible. The balance between attraction and release, the delicate tension that allows matter to breathe, is what gives the universe its stability and its grace. Even the strong and weak nuclear forces must exist in harmony. The strong force, which binds atomic nuclei, must be fierce, but not too fierce. If it were stronger, All hydrogen in the universe would have fused within seconds of the Big Bang, leaving no fuel for stars, no water. If weaker, atomic nuclei would never hold together, and the universe would be nothing but a cloud of lonely particles. The weak force, too, must walk its own narrow path. If it acted just a little differently, stars would not shine steadily. They would either flare into chaos or fail to ignite at all. These balances, so fine, so exact, form what scientists call the anthropic window, the narrow range of physical conditions that allow life, and indeed any form of order, to exist. Out of the infinite possibilities for chaos, the universe chose harmony. It's almost humbling to realize how small the margins are. The constants of physics, the gravitational constant, the charge of the electron, the mass of the proton, are tuned with such exquisite precision that even a change in the 40th decimal place could erase galaxies before they begin. It's as if reality itself is walking a tightrope across the void, one misstep away from silence. And yet, here we are, 13.8 billion years after the Big Bang. The universe still holds. Stars burn, planets orbit, atoms endure. Somehow, through the interplay of the four forces, everything remains in motion, balanced between collapse and expansion, fire and stillness. Perhaps balance is the universe's most profound truth. Every force is countered by another, every tension answered with its opposite. Gravity gathers, expansion pushes away, energy burns, matter cools. Destruction feeds creation. From this eternal opposition, the cosmos finds peace. You are part of that balance. The atoms in your body obey the same precise rules, tuned perfectly to exist. Every breath, every heartbeat, every flicker of thought is a product of that cosmic harmony. You are not separate from the universe's balance. You are the balance, a living expression of the same fragile perfection that holds the stars in place. And when you look up at the night sky, filled with light and silence, remember, it all endures because the universe learned how to stay perfectly still between too much and too little, between chaos and collapse, between nothing and everything. Imagine walking a line where one misstep leads to nothingness. That is the path our universe walks, forever balanced between creation and destruction. Every moment since the beginning of time has been an act of balance. The cosmos is not a static thing. It teeters, constantly, on the edge of opposites. Too much gravity, and it would have collapsed into a singular mass long ago. Too much expansion, and it would have torn itself apart before a single atom could form. Instead, the universe found equilibrium, a delicate harmony that allows both motion and stability, both life and death, both order and chaos to coexist. From the very first instant after the Big Bang, the universe began walking this invisible tightrope. In that primordial flash, energy raced outward, countered by gravity's pull inward. For the next 13.8 billion years, those two forces would remain locked in a quiet contest, neither winning, neither surrendering. The expansion of space and the weight of matter exist in perfect opposition, defining the tempo of cosmic evolution. If either gained too much ground, everything we know would cease to exist. This fragile symmetry extends to the smallest scales as well. In every atom, opposing charges, positive and negative, balance one another so precisely that matter can hold its shape. Protons repel each other with tremendous force, yet the strong nuclear force holds them close, neither allowing collapse nor escape. Even the light that travels through space owes its existence to equilibrium, an oscillation between electric and magnetic fields, eternally intertwined. The entire universe, from galaxies to photons, depends on tension held in perfect measure. And yet, this balance is not static, it is dynamic, alive. Galaxies spin, stars explode, black holes feed, and new worlds are born, all while the cosmic scale remains finely poised. Even decay has its role. As stars exhaust their fuel, they die, scattering elements that form new generations of suns and planets. Destruction, in this universe, is not the opposite of creation. It is the condition that makes creation possible. It's astonishing to think how small the margins truly are. If the gravitational constant were slightly stronger, the universe's expansion would have reversed billions of years ago. If it were weaker, galaxies would never have formed. The same is true of the nuclear forces, the charge of the electron, even the density of dark energy, each tuned to an almost impossible degree of precision. Like a cosmic acrobat, the universe balances on these narrow values, wobbling gently but never falling. Even time itself walks this tightrope. Too much entropy, and the universe would be pure chaos. Too little. Instead, time flows forward, carrying energy from order to disorder in just the right measure to allow evolution, growth, and thought. You are, in a sense, part of that balancing act, a momentary expression of energy held between structure and decay. When you gaze at the night sky, you are looking at this cosmic balance in motion. Every star you see is a tension resolved, gravity pulling inward, nuclear fire pushing outward. Each twinkle is a symbol of harmony maintained. The universe is not at rest. It is forever moving along its tightrope, guided by laws so precise they might as well be choreography. And perhaps that is the true miracle, that in a universe balanced so precariously between extremes, anything at all can exist. That stars can burn without consuming themselves too quickly. That matter can endure without flying apart. That consciousness can arise and look back upon it all, aware of the narrow line it walks. The universe does not fall because balance is written into its nature. It is not luck, it is law. The four forces, in their silent unity, keep reality suspended in perfect tension. And so, existence continues, step by step, moment by moment, walking the infinite tightrope between being and nothingness. Every heartbeat, every orbit, every falling apple is gravity in motion. It binds the cosmos but also gives birth to intimacy, the way planets embrace their suns and moons their worlds. We often think of gravity as something grand, something that sculpts galaxies and anchors the stars. But its true beauty lies in its gentleness, in the quiet, invisible pull that threads together everything that exists. From the soft tug that keeps your feet on the ground to the cosmic embrace that holds entire solar systems in balance, gravity is both the architect of the heavens and the unseen caretaker of life itself. When you drop a stone, it falls not because the earth demands it, but because both are drawn together. Every object in the universe, no matter how large or small, reaches out to every other. It is not domination, it is connection. The apple falls to the ground for the same reason the earth orbits the sun. They are in conversation through the fabric of space-time, drawn toward one another in a relationship that never ends. Gravity is not just a cosmic force, it is the universe's most ancient form of affection. It pulls without touching, it binds without breaking, it holds without control. The planets are forever falling toward their stars, but their momentum keeps them suspended, like dancers circling one another in a slow, eternal waltz. The same principle governs everything, from the tides of the sea to the arcs of comets wandering through deep space. On Earth, gravity shapes not only the physical world, but the living one. It is the reason rivers flow downhill, carving valleys and nourishing life. It guides the growth of plants, pulling their roots into the soil and their stems toward the light. It even helps shape the rhythms of your body, your heartbeat, your circulation, your sense of balance, all finely tuned to the gentle pull of the planet beneath your feet. In the cosmic sense, gravity is what allows life to have a home at all. It gathers dust into planets, holds atmospheres in place, and creates the warmth and stability needed for biology to flourish. Without it, the Earth would drift apart, its air and oceans stripped away into the void. Every sunrise, every gentle breeze, every stable orbit is gravity's gift. A promise of continuity, amid the chaos of space. But gravity's influence extends far beyond life as we know it. It forges stars in the darkness, compressing clouds of gas until nuclear fire ignites. It births galaxies, organizing billions of suns into elegant spirals. And in the end, it gathers everything back again. Stars collapsing into black holes, galaxies merging in luminous collisions, matter falling once more toward the center. Even destruction, under gravity's hand, becomes an act of creation, seeding new beginnings from what came before. Perhaps this is why gravity feels so familiar, because, in its essence, it mirrors something deeply human. It is the force of belonging, of closeness, of return. It reminds us that everything yearns towards something else, that nothing exists in isolation. Even across billions of light years, gravity connects what would otherwise remain forever apart. You are bound by it, not as a prisoner, but as a participant in its endless conversation. The pull you feel when you stand upon the Earth is the same pull that binds galaxies together, that shapes the stars you see above. The same law that keeps your body grounded also keeps your world alive. Gravity is the quiet heartbeat of the cosmos, slow, patient, constant. It is the gravity of life itself, the pull that unites every being, every world, every atom, in the shared rhythm of existence. When you touch metal, feel static, or see a lightning storm, you're witnessing the electric personality of the universe, an invisible tide that connects stars to synapses. Electricity and magnetism are not separate forces, but two sides of the same cosmic coin. They weave together into electromagnetism, the most expressive of the universe's four fundamental forces. It is energy in motion, charge in conversation, and it moves through everything, from the distant arcs of cosmic lightning that streak across nebulae to the faint spark of thought that flickers through your brain. Every living thing hums with electricity. The rhythm of your heartbeat, the firing of your neurons, even the exchange of oxygen in your blood are all powered by tiny electric currents. In that sense, the same physics that lights a supernova also lights the mind. The voltage that runs through a storm cloud and the current that carries a thought across your synapses are born of the same law, the same magnetic pulse that shapes the stars. Electromagnetism gives the universe its vibrancy. When charged particles move, they generate magnetic fields that stretch out through space like invisible rivers. These fields can twist, bend, and combine, forming vast networks of energy that guide matter itself. They sculpt the shapes of galaxies, fuel the auroras that shimmer over polar skies, and carry radio waves that whisper through the cosmos. You can think of it as the nervous system of the universe, a web of invisible signals constantly in motion. The sun's magnetic field stretches far beyond its surface, forming the heliosphere that protects every planet in our solar system from cosmic radiation. Here on Earth, the planet's own magnetic field shields us too, deflecting solar winds and painting the sky with northern and southern lights, ghostly curtains of charged particles dancing through the night. But electromagnetism isn't just external, it is intimate. It defines how atoms interact, how molecules bond, how your eyes perceive light. The very concept of color is electromagnetic, light waves vibrating at different frequencies, translated by your brain into sensation and meaning. Every red sunset, every flash of lightning, every gentle glow from a firefly, all are the visible expressions of this same universal pulse. Even in silence, electromagnetism hums. It is the background field through which light travels, the bridge between energy and matter. Without it, there would be no chemical reactions, no warmth, no spark of awareness. It keeps the universe dynamic, alive, ever-changing. And perhaps that is what makes it so profound. It unites the grand and the personal. The magnetic storms that ripple across the surface of the sun are echoed in the faint electrical whispers of the human mind. The same equations that describe the lightning that splits the sky also describe the flow of charge that allows you to think, feel, and dream. In this way, electromagnetism is more than a force. It is connection itself. It's the invisible bridge that links atoms into molecules, planets to their stars, and living beings to the universe around them. It's the constant conversation between motion and stillness, attraction and release. So when you see lightning flash, or feel the shock of static on your fingertips, remember, you are touching the same energy that threads through the cosmos. The same pulse that powers the stars flows quietly through you. The universe does not merely move, it vibrates. And through electromagnetism, every particle, every planet, every thought hums together in a shared, magnetic rhythm, the pulse of being itself. Light itself is a child of electromagnetism, a wave that needs no medium to travel. Every sunrise, every nebula, every galaxy glows because of this shimmering relationship between electricity and magnetism. It's almost poetic, something born of nothing, moving through emptiness faster than anything else in existence. Light has no mass, no substance, yet it defines everything we see. It is the messenger of the universe, carrying information across billions of years and unimaginable distances. Every color, every reflection, every glimmer that has ever touched your eyes is a ripple in the electromagnetic field, energy woven into motion. Light began not long after the universe itself. In the first moments after the Big Bang, the cosmos was a dense fog of particles, too hot, too chaotic for photons to escape. For hundreds of thousands of years, light was trapped, endlessly scattered by matter, unable to move freely. Then, as the universe expanded and cooled, atoms formed and the fog cleared. Photons were finally released, rushing outward into open space. That moment, known as recombination, was the birth of light as we know it. The faint afterglow of that event still surrounds us today, the cosmic microwave background, a whisper from the dawn of time. Light is more than illumination. It is a storyteller. Every beam that reaches us from the depths of space carries a record of its origin. It tells us what stars are made of, how galaxies move, and how fast the universe expands. The light from distant quasars is a message sent billions of years ago, arriving only now, long after its source has faded into silence. To see the night sky is to see into the past, to witness ancient light still traveling through the dark. At its core, light is both wave and particle, a paradox that reveals the dual nature of reality itself. It vibrates as an electromagnetic wave, an oscillation of electric and magnetic fields dancing together in perfect harmony. But it also arrives in tiny packets called photons, discrete bursts of energy that can power a solar cell, ignite a chemical reaction, or strike the receptors in your eyes to spark the experience of sight. It is both continuous and quantized, both smooth and sharp, proof that the universe delights in mystery. Every living thing on Earth depends on this cosmic gift. The light of the sun fuels the photosynthesis that feeds the planet. It warms oceans, drives winds, and shapes the cycles of life. The photons that travel across 93 million miles to reach us carry energy born in the sun's core, created by fusion under the watch of the weak and strong nuclear forces. In that sense, every sunrise is not just a daily occurrence, it's the result of physics spanning the scales of the cosmos, from the subatomic to the galactic. Light also defines beauty itself. It paints the auroras that ripple across polar skies, the pinks and oranges that grace a sunset, the shimmering clouds of interstellar dust that glow in nebulae. The universe's artistry is written in light, the brushstrokes of electromagnetism across the canvas of space. And yet, for all its brilliance, light is humble. It asks for nothing, carries everything, and never slows. Even when no one is watching, it continues its journey, crossing the gulfs between galaxies, illuminating the dark just by being. When you see light, you are not merely witnessing energy. You are seeing a thread that connects every level of existence. From the quantum hum of electrons to the spiraling arms of galaxies, it is the same phenomenon, unchanged since the dawn of time. Light is the language of the universe. the visible heartbeat of electromagnetism. It travels freely, needing no guide, no path, only the endless invitation of space. Every star that burns, every atom that glows, every world that sees owes its existence to this single, miraculous child of energy and motion, the birth of light. The strong nuclear force works in silence, holding atomic hearts together. It is the power that lets stars forge elements and build the very dust from which you are made. It is the most powerful force in existence, and yet the most hidden. You never feel it directly. It does not move planets, or create lightning, or flow through your body like electricity. Its realm is far smaller, confined to the very core of matter itself. But within that tiny space, the strong force reigns supreme, overpowering every other interaction in nature. Without it, no atom could exist, no star could shine, and no life could ever emerge. Inside the nucleus of every atom, protons and neutrons sit packed together in impossible proximity. By all logic, they should explode apart, their positive charges repelling one another like magnets forced too close. But the strong force defies that logic. It binds them, weaving their conflicting energies into unity. It doesn't just resist separation, it demands connection. In this way, the strong force is the ultimate paradox. A power so intense it can hold the universe together, yet so confined that it acts only across distances smaller than a single proton. The secret lies in its messengers, gluons. These almost weightless particles constantly dart between quarks, the building blocks of protons and neutrons, exchanging energy at unimaginable speeds. They create a web of tension so tight that if you try to pull two quarks apart, the force between them doesn't weaken, it grows. And if stretched far enough, that tension becomes so immense that new particles simply appear, as if reality itself refuses to be separated. The strong force does not permit loneliness at the subatomic level. This same stubborn power drives the universe's most creative acts. In the hearts of stars, where temperatures soar to millions of degrees, atomic nuclei collide with such ferocity that the strong force takes hold, binding them together into new elements. Hydrogen becomes helium, helium becomes carbon, oxygen, and beyond. Every heavier atom in the cosmos, every grain of dust, every drop of water, every living cell was built through this chain of fusion. It is the strong force that allows the universe to transmute simplicity into complexity. And when stars die, it is once again the strong force that decides their fate. As nuclear fuel runs out, gravity begins to win, crushing the star's core. But the strong force resists until the final moment, until even its mighty bonds can no longer hold. The result is a supernova, a detonation so powerful it scatters the elements of creation across galaxies. In that instant of destruction, the strong force releases everything it has built, seeding space with the raw materials of life. The gold in your jewelry, the calcium in your bones, the iron in your blood, all were born from the strong force's final act of surrender. If gravity writes the structure of the universe, the strong force writes its substance. It is the unseen architect of matter, the quiet flame that turns the chaos of energy into the stability of atoms. Every molecule, every cell, every living thing owes its existence to its invisible embrace. It is the most secret of all cosmic powers, not because it hides, but because it does not need to reveal itself. You don't see it, but you are it. Every atom in your body is held together by this silent strength. The strong force lives in you, unchanged since the dawn of time, steady, invisible, eternal. In a universe ruled by motion and decay, it is the strong force that reminds us what it means to endure. It is the promise written into every atom that even in a reality built on impermanence, there is still something that holds. In stellar furnaces, the strong and weak forces weave new matter. Hydrogen becomes helium, helium becomes carbon. And in that slow fusion, life's ingredients are born. Every star you see glittering in the night sky is a laboratory of creation, a cosmic forge where the most fundamental forces in nature come together to perform their grandest act, turning simple atoms into the complex building blocks of existence. Deep within their blazing cores, the strong and weak nuclear forces work side by side, fusing, transforming, and sculpting the matter that will one day form worlds, oceans, and living beings. It begins with the simplest element, hydrogen, the most abundant material in the universe. Under immense pressure and heat, hydrogen atoms are forced so close together that their mutual repulsion is overcome. The strong force reaches across the smallest distances imaginable and binds them, fusing two protons into one nucleus. In that instant, the weak force steps in, subtly transforming one proton into a neutron, releasing energy in the form of light. That light, born of nuclear transformation, streams out into the universe as the warmth that sustains planets and the brilliance that fills the sky. Over millions of years, this process continues in layers, each stage creating heavier elements. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, neon, silicon, and eventually iron, the heaviest element a star can forge in its core through fusion alone. Each step is a conversation between the strong and weak forces, between binding and change, between holding and releasing. It is not violence, but craftsmanship, an art form on a cosmic scale. And when that art reaches its limit, something extraordinary happens. Once iron fills a star's core, fusion can no longer continue. It costs more energy than it gives. The balance breaks, gravity begins to crush the core, and in the star's dying moments, the forces that once created now destroy. Yet even in destruction, creation continues. In the explosive death of a supernova, atoms collide with such ferocity that entirely new elements are born. Gold, silver, uranium, and all the rare materials scattered across the cosmos. These remnants drift through interstellar space, becoming the seeds from which new stars and planets will one day form. Our sun, too, was born from that debris, a second-generation star forged from the ashes of older ones. The carbon in your body, the calcium in your bones, the oxygen you breathe, all trace back to stars that lived and died long before our world existed. You are, in every sense, made of starlight, condensed into form. The elements that allow you to think, to move, to feel, each one was crafted in a furnace billions of years ago, fused from hydrogen by the same forces that still burn above us tonight. This is the true alchemy of the cosmos, not the turning of lead into gold, but the transmutation of energy into life. The strong force binds matter, the weak force transforms it, and together they write the chemistry of everything. From this cooperation, the universe creates not just stars, but possibility itself. When you look up at the sky, you are not merely seeing points of light, you are witnessing history, energy, and memory made visible. Every shimmer is a star performing the same act of creation that once made you. Each one burns with the same purpose: to transform, to give, to become. The stars are the universe's greatest storytellers, and the story they tell is always the same: how out of pressure, heat, and invisible forces, existence itself was forged. The next time sunlight warms your skin, remember that warmth began in a nuclear furnace, born from the dance between the strong and weak forces, carrying across space to remind you that you, too, are part of the alchemy of stars. For decades, physicists have dreamed of a single theory, a grand unification where gravity and quantum forces merge. Somewhere in that unity lies the secret of existence itself. From the beginning, science has revealed a universe built on patterns, symmetries that repeat, principles that echo across scales. The more we learn, the more we realize that the four fundamental forces, gravity, electromagnetism, the strong, and the weak, are not separate chapters, but verses of one unfinished song. Each describes a different way that nature interacts, but their boundaries blur at the edges. Somewhere beyond our current understanding, they may all converge, merging back into the single, elegant force that existed in the universe's earliest moments. The quest to find that unity has become one of the greatest scientific journeys of all time. It's called the search for the theory of everything, a framework that explains how the cosmos behaves from the smallest quantum flicker to the largest galactic cluster. At one end of this spectrum lies general relativity, describing the smooth curvature of space-time shaped by gravity. At the other end lies quantum mechanics, a world of probabilities, uncertainty, and discrete particles where the strong, weak, and electromagnetic forces dominate. Each theory works flawlessly in its own domain, yet when we try to make them coexist, they rebel. Gravity, in particular, resists the quantum world. It's a gentle giant, weak on small scales but infinite in reach, while the quantum forces thrive in chaos, flickering in and out of existence within fractions of a second. When we try to describe gravity in the same mathematical language as the others, the equations break down into infinities, refusing to make sense. It's as though nature speaks two dialects of the same language, one cosmic, one microscopic, and we are still learning how to translate between them. And yet, there are clues that unity once existed. In the moments just after the Big Bang, when the universe was smaller than an atom and unimaginably hot, physicists believe the four forces were one. Only as the universe expanded and cooled did they diverge, breaking symmetry in a cosmic unfolding. The strong force separated first, then the weak and electromagnetic forces split apart, and finally, gravity became distinct. The laws that govern stars and atoms today may all be echoes of that original, unified principle. Modern physics has come close to reuniting them. The electromagnetic and weak forces, once thought entirely separate, are now known to be two expressions of a single electroweak interaction. This breakthrough hints that further unification is possible, that even the strong force and gravity may one day join the same equation. The search continues through string theory, quantum gravity, and other bold frameworks, each an attempt to uncover the bridge between the cosmic and the quantum. If we could find that bridge, we would not just understand the universe, we would understand why it exists at all. We might finally see how space, time, matter, and energy emerge from one common source. Perhaps the universe began not as a burst of chaos, but as a single vibration, one note that expanded, resonated, and diversified into everything we see. Even if we never discover the full theory, the pursuit itself is a reflection of the universe's nature. Just as the four forces seek balance, so do we seek understanding. Our curiosity mirrors the harmony we study. We are fragments of the cosmos trying to remember what it was like to be whole. The bridge between forces may not just be mathematical, it may be philosophical. A reminder that all divisions are illusions, that every difference between light and gravity, particle and wave, matter and energy is only perspective. Beneath it all, there may be just one force, one pattern, one origin. And if that's true, then every atom, every star, every living thing is part of a single, continuous thread stretching back to the dawn of time, a bridge connecting everything that ever was and ever will be. On the smallest scales, gravity seems to disappear, replaced by jittering probabilities and uncertain positions. Yet, those same probabilities give rise to everything solid you see. At the boundary between the cosmic and the microscopic, the universe stops behaving like a machine and begins to act like a dream. In this strange, subatomic world, particles flicker in and out of existence, appear in two places at once, and seem to decide their behavior only when observed. Here, gravity, so dominant on galactic scales, fades into near irrelevance, and the universe is ruled instead by chance, uncertainty, and the quiet logic of quantum mechanics. It's a realm that defies intuition. When you look at an object, a stone, a tree, your own hand, it feels stable, solid, predictable. But dive deep enough, past molecules and atoms, past the protons and neutrons at their cores, and you find a world where nothing stays still. Particles swarm like fireflies in the dark, vibrating with energy even in perfect vacuum. They don't orbit like planets or move along neat trajectories. Instead, they exist as probability clouds, mathematical whispers of where they might be, rather than where they are. This uncertainty isn't a flaw, it's the foundation of everything. The fuzziness of the quantum world allows electrons to settle into orbits, creating atoms stable enough for chemistry to exist. Without uncertainty, every particle would collapse into the same spot, and the universe would be a lifeless singularity. What looks like chaos is, in truth, the elegant balancing act that gives matter its shape and energy its form. Physicists call this delicate tension the quantum tug-of-war. On one side is the smooth curvature of Einstein's space-time, where gravity rules with predictable grace. On the other is the jittering, probabilistic world of quantum fields, where nothing is certain and everything is connected by invisible vibrations. Between them lies a mystery science has yet to solve. How do these two realities, so different in nature, coexist in one universe? When we try to describe gravity in quantum terms, the equations explode into infinities. When we try to describe particles using Einstein's geometry, space-time itself breaks down into a foaming chaos. The universe seems to have drawn a line, one side classical, the other quantum, and dared us to find the bridge. And yet, it is within that tension that everything we know emerges. The stability of stars, the structure of atoms, the light that fills the sky, all depend on this uneasy partnership. The strong and weak nuclear forces govern the quantum realm, holding nuclei together and allowing transformation. Electromagnetism gives structure to matter, binding electrons to atoms. Gravity, though faint here, remains a subtle background influence, linking the microscopic to the cosmic in ways we're only beginning to understand. Even empty space is not truly empty. Quantum theory tells us it's alive with fluctuations, fields vibrating, particles appearing and vanishing in pairs, energy borrowing and repaying itself in the blink of a Planck second. This restless energy, invisible yet omnipresent, might be the origin of gravity itself, or even the key to the universe's expansion. It's humbling to realize that everything solid, stable, and familiar arises from this invisible storm. The table beneath your hand, the air you breathe, the photons striking your eyes, all are the products of uncertainty, emerging from a sea of possibilities. You are built from probability, stabilized by balance, defined by forces that never truly rest. The quantum tug-of-war is not a conflict, it's a collaboration. The push and pull between chaos and order, between chance and structure, between gravity's calm and quantum turbulence, is what allows existence itself to unfold. At the smallest scales, the universe reminds us of its dual nature. It is both wave and particle, dream and geometry, question and answer. And somehow, through this eternal tension, everything that seems solid, certain, and real, you, me, the stars themselves, is born from the shimmer of the uncertain. The universe depends on numbers that never change, the charge of an electron, the speed of light, the strength of each force. Alter any one of them, and everything ceases to exist. In all the vastness of space, amid the chaos of explosions, collisions, and evolution, there lies an astonishing stillness, an order so precise that even the universe's wildest phenomena obey it. This order is written in the constants of nature, the unchanging numbers that govern how reality behaves. They are the silent metronomes of creation, ticking in perfect rhythm since time began. There's the gravitational constant, determining how strongly masses pull one another. The speed of light, setting the ultimate limit for motion and communication. The Planck constant, defining the quantum world's smallest possible action. The fine structure constant, controlling how strongly light and matter interact. Each one is not just a number, but a thread woven so tightly into the fabric of existence that even the slightest variation would unravel the cosmos. Imagine if the electron's charge were different by even a fraction. Atoms would not form stable orbits. Chemistry would fail. The stars could not fuse elements, and matter, as we know it, would never arise. If the speed of light changed, the balance between energy and mass, so delicately expressed in Einstein's equation, E equals mc squared, would collapse, altering the energy output of every reaction in the universe. Even the tiniest deviation in the gravitational constant would mean the difference between a universe that collapses in on itself and one that expands too fast for galaxies to form. It's as though reality sits on a knife's edge, its laws balanced to perfection. We call this fine-tuning, but the term hardly captures the enormity of what it means. Out of infinite mathematical possibilities, our universe chose values so specific, so consistent, that they allow matter to endure and life to think about it. Change the constants by 1 part in a trillion, and the delicate symmetry between the 4 forces would shatter. Stars would die unborn. Space would remain dark. There would be no question of life, because there would be no structure, no time, no meaning. Physicists have long wondered why. Why these numbers? Why not others? Are we simply lucky, inhabitants of a universe whose constants just happen to permit existence? Or is there something deeper, a principle of balance that makes these values inevitable? Some theories suggest that countless universes may exist, each with its own constants, most sterile and lifeless. We just happen to live in one that works. Others imagine that these constants are not random at all, but the necessary outcome of mathematics itself, values that could not have been otherwise. Whatever the truth, one thing is certain: the constancy of these numbers is the foundation of everything. They are the universe's promises, unchanging, unwavering, eternal. The electron will always carry its same charge, the speed of light will never falter, the ratio of mass to energy will forever hold. Without this reliability, there would be no pattern, no cause, no consequence, only chaos. And yet, their precision feels almost fragile, like glass stretched thin across infinity. The universe persists only because its constants never blink, never drift, never forget. In that stability lies all the motion, all the color, all the beauty you've ever seen. Every star that burns, every atom that bonds, every heartbeat that echoes through the dark, all depend on these sacred numbers, perfectly balanced and forever faithful. So when you gaze at the sky and wonder how something so vast could feel so ordered, remember this: the cosmos endures not because it is strong, but because it is precise. Its very existence rests on the fragile perfection of constants that never change. By all accounts, matter and antimatter should have annihilated each other in the first second. And yet, something tipped the scales ever so slightly in our favor. We are that imbalance. When the universe was born, it came into being with perfect symmetry. For every particle of matter created, there was an identical twin of antimatter, a mirror reflection with the same mass but opposite charge. In theory, that should have been the end of the story. When matter and antimatter meet, they obliterate one another, releasing pure energy in a burst of light. The result should have been a universe filled with nothing but radiation, brilliant for a moment, then silent forever. But that isn't what happened. Somehow, against all expectation, a tiny fraction of matter survived. For every billion pairs of particles that destroyed one another, one single extra particle of matter remained. That 1 in a billion imbalance became everything. Every galaxy, every star, every planet, every breath you take, all made possible because the universe broke its own symmetry. The question of why it did remains one of the greatest mysteries in physics. What mechanism, what subtle bias, allowed matter to win by the slimmest of margins? Scientists call this phenomenon baryon asymmetry, and it may hold the key to understanding why anything at all exists. Some believe the answer lies in the weak nuclear force, the quiet alchemist that allows particles to change identities. Unlike the other forces, the weak force does not treat matter and antimatter equally. It plays favorites, ever so slightly, introducing a tiny imbalance in the earliest moments of creation. In that microscopic unfairness, the universe found its future. It's humbling to think that every atom in your body is the result of this cosmic imperfection. The carbon in your cells, the oxygen you breathe, the iron in your blood, all trace their origin to that initial asymmetry. If the scales had been balanced perfectly, nothing solid would exist. No stars to burn, no planets to form, no life to wonder why. Perfection, it turns out, would have meant oblivion. Instead, the universe chose a flaw, a minuscule error written into the equations of creation, a gentle tilt that allowed matter to edge out antimatter. From that flaw came everything: structure, energy, time, life. It is as if the cosmos understood that to exist, it must not be perfect. Even today, traces of that early annihilation echo through the void. The faint afterglow of the Big Bang, the cosmic microwave background, is the lingering whisper of matter and antimatter's ancient war. Yet that whisper is also a song of survival, proof that imbalance can give rise to beauty. Perhaps there's something profound in that idea. That all of existence, from the birth of galaxies to the beating of your heart, depends on imperfection. That a single cosmic asymmetry, so small it could have gone unnoticed, became the seed of every world, every star, every thought. The universe, by all logic, shouldn't exist. And yet here it is, burning, expanding, alive. You are the embodiment of that defiance, a collection of improbable atoms born from a universe that refused to cancel itself out. So when you look at the stars and feel the weight of their distance, remember, you are not just a bystander of the cosmos, you are its remainder, the tiny fraction of matter that overcame its mirror image, the universe's rarest survivor. The proof that imperfection, against all odds, can create everything. Every atom in your body is made of the tiniest fraction of matter that survived annihilation. You are, quite literally, the universe's rarest residue. In the first second of existence, the universe was a battlefield. Matter and antimatter met in perfect pairs, colliding and erasing each other in flashes of pure light. The energy released from that war still hums faintly across the cosmos, a relic we can detect as the cosmic microwave background, a ghostly afterglow of a universe that nearly destroyed itself before it began. And yet, somehow, impossibly, not everything vanished. For every billion particles that annihilated, one lonely particle of matter remained. That fraction, a mere whisper of existence, became the foundation of everything. The galaxies, the stars, the planets, and you. Everything that has form, weight, and memory was born from the leftovers of that ancient imperfection. To call it luck doesn't feel sufficient. It was precision, an imbalance so small and so exact that it allowed the universe to avoid both extremes, endless nothingness and infinite energy. Out of that sliver of survival came atoms. Out of atoms, molecules. Out of molecules, life. The universe built everything we know from the tiniest remainder imaginable. Think of what that means. Every breath you take, every thought that sparks through your mind, is powered by matter that has endured for 13.8 billion years. The particles that make up your body, the carbon, oxygen, nitrogen, and iron, have been recycled countless times, through stars, through planets, through the quiet churn of cosmic time. You are not just part of the universe, you are its persistence made visible. The atoms in your hand were once part of something ancient. Some were born in the hearts of massive stars, others drifted through space for eons before being gathered into the cloud that became our solar system. The hydrogen in your blood was forged in the first few minutes after the Big Bang itself. You carry in you the original light of creation, condensed into living form. It's humbling to realize that existence itself is a cosmic accident, a momentary imbalance that refused to fade. And yet, from that accident, came the possibility of beauty, consciousness, and curiosity. The same imperfection that saved the universe also gave rise to beings capable of wondering why. Perhaps that's what makes life so precious. It isn't inevitable, it's improbable. Against the pull of symmetry, against the tide of annihilation, existence found a way to remain. The stars that shine above you and the cells that breathe within you are both born from that same stubborn fraction of matter that refused to vanish. The universe is mostly emptiness, mostly silence, but not entirely. You are proof of what happens when something endures against the odds, a remnant of the first second, carrying the memory of a near-perfect balance that was broken just enough to let creation begin. So, when you look at your reflection, know that you are looking at the cosmos itself, ancient, improbable, and enduring. You are the universe's leftover light, the residue of imperfection, the fraction that became everything. The same four forces that hold galaxies together also shape the molecules in your body. Gravity, electromagnetism, the strong and the weak, they all live inside you. You are not separate from the universe. You are the universe, condensed into form, a fleeting arrangement of stardust governed by the same invisible laws that shape the stars. Every atom in your body, every molecule that breathes life into you, is bound, balanced, and sustained by the four fundamental forces. The vastness of the cosmos isn't something out there, it's happening right here, within your very cells. Gravity, though faint within you, gives you weight and belonging. It's the reason you stand on Earth, the quiet connection that anchors you to this world. But its influence goes deeper still. Gravity ties you to every other object in existence, however distant. The atoms that make up your body tug imperceptibly on the moon, the stars, and the galaxies themselves. You are linked by this gentle thread to everything that has ever been. Electromagnetism gives you light, warmth, sensation, and life itself. It's the architect of atoms and the spark behind every heartbeat. It governs the bonds between your molecules and the flow of thought through your neurons. The electricity that powers your mind is not a metaphor. It is the same force that paints the auroras and drives lightning across alien skies. Every flash of imagination, every spark of emotion, is the echo of the cosmos made intimate. The strong nuclear force works quietly within you, holding together the atomic hearts of every cell. It is the reason your atoms exist at all, the reason you have structure, solidity, and substance. Without it, the very particles that make you would dissolve into formless energy. Inside each atom, deep within the nucleus, the strong force binds protons and neutrons so fiercely that even the heat of stars cannot break them apart. And then there is the weak nuclear force, the alchemist within. It allows atoms to change, to decay, to transform. It powers the chain reactions inside the sun, and through its influence, the elements that compose you were once created in the furnace of dying stars. Every breath you take contains traces of those transformations, the ongoing dialogue between decay and renewal, between what was and what is. All four forces act within you in perfect harmony. They balance strength with subtlety, endurance with change. You are their meeting point, the place where the laws of the universe converge into something that can ask, why? When you move, when you think, when you dream, those same cosmic principles are at play. Your thoughts ripple with electromagnetic currents. The atoms of your bones are stitched together by the strong force, the energy that fuels your life once radiated from fusion in distant stars. Even your mortality, the slow decay that will one day return you to the earth, is guided by the weak force's quiet hand. It's astonishing to realize that the forces that sculpt galaxies also sculpt you. You are not small compared to the universe. You are its reflection, its echo, its awareness. The cosmos did not create you as something apart from itself. It created you to be a continuation of its pattern. When you look up at the night sky and see the stars burning far away, remember, the same laws that keep them alive are the ones that keep your heart beating. The same balance that sustains galaxies sustains you. You are gravity, you are light, You are strength. You are transformation. You are the universe made conscious, an assembly of the four forces, harmonized into thought, wonder, and life itself. Inside each atom, protons and neutrons fight against repulsion. Electrons whirl in their electric cages, and energy dances between the stable and the unstable, an eternal atomic ballet. If you could peer deep enough into the heart of matter, beyond the limits of sight and imagination, you'd witness a realm that is anything but still. Inside every atom, a quiet war rages, one that has been unfolding since the dawn of time. The strong nuclear force holds the nucleus together, while electromagnetism tries to tear it apart. The result is a ceaseless tension, a delicate balance between attraction and repulsion that defines the structure of everything you've ever touched or seen. Protons, each carrying a positive charge, should repel one another with immense force. Yet the strong force, 10 million times more powerful than electromagnetism, binds them tightly, using an invisible glue of gluons and quarks. Neutrons, neutral in charge, act as peacekeepers, adding mass and stability, reducing the electric push that would otherwise tear the nucleus apart. Every atom is a fragile compromise, a truce negotiated between opposing powers. Beyond the nucleus, electrons swirl in quantized orbits, not like tiny planets, but as waves of probability, fuzzy regions where their presence is most likely to be found. They are held close by electromagnetic attraction, but never allowed to fall inward, their motion sustained by the strange certainty of quantum uncertainty. It is this motion, this perpetual dance, that keeps matter from collapsing into itself. Even within apparent stillness, there is motion. Every atom in your body hums with activity. Its particles vibrate, spin, and exchange energy in infinitesimal bursts. The bonds between atoms stretch and contract like the strings of an invisible instrument, resonating with the frequencies of heat, light, and sound. You are, quite literally, made of movement frozen into form, a living pattern of energy held in constant negotiation. This hidden war is not destructive, it's creative. The tension between forces gives rise to stability, and that stability makes chemistry possible. The way atoms share electrons, the way molecules form, the way matter takes shape, all stem from the equilibrium between the strong nuclear force pulling inward and electromagnetism pushing outward. The atom survives not because the battle ends, but because it never does. Yet within that balance lies constant transformation. Some nuclei are stable for billions of years, while others decay in fractions of a second, their particles reshaping into new forms through the weak nuclear force. Radioactive decay, nuclear fusion, fission, all are echoes of this quiet cosmic struggle, a reminder that even permanence is only temporary when viewed closely enough. You can think of it as an eternal performance. The strong force plays the deep bass that anchors the atom. Electromagnetism provides the melody of attraction and repulsion. The weak force introduces rhythm through decay and change. And gravity, though faint here, keeps the entire orchestra in harmony on a cosmic scale. Together, they compose the music of matter. Every structure in the universe, from mountains to galaxies, exists because of this invisible balance. It's astonishing to realize that something as stable as a rock, as solid as your own body, is really the product of opposing forces locked in endless motion. So when you rest your hand on a table or watch sunlight fall through the air, know that within that stillness, trillions of atomic wars are being fought and won every instant. The universe, it seems, never truly stands still. It only hides its movement well. Every element inside you was created in a star's nuclear heart through the cooperation of the strong and weak forces. You are, in every way, the echo of a cosmic explosion. Long before there were oceans, planets, or the notion of life, there were only stars, vast, burning furnaces where matter itself was learning how to create. Inside their cores, the strong nuclear force worked tirelessly, binding protons and neutrons together in defiance of their mutual repulsion. Each fusion released unimaginable energy, and with every reaction, the universe grew richer in complexity. The weak nuclear force joined in, transforming particles and balancing the reactions that made this cosmic chemistry possible. It was in this union, the marriage of strength and transformation, that creation truly began. At first, these stars produced only simple elements: hydrogen fused into helium, helium into carbon, and carbon into oxygen. Layer by layer, as stars aged, they built heavier and heavier atoms: neon, silicon, and finally, iron. But even a star has limits. When it could fuse no more, its core collapsed under its own gravity. In that final, catastrophic moment, the balance between forces broke, and a supernova was born, a titanic explosion so powerful that it outshone entire galaxies. Within that blinding burst, the universe found its forge. Temperatures soared high enough for atoms to collide with such violence that new elements were born: gold, silver, copper, uranium, the very materials that would one day form mountains, oceans, and living cells were created in the chaos of a dying star. Then, scattered by the blast, those elements drifted into the dark, forming clouds of stardust that would one day collapse again, giving birth to new stars, new planets, and eventually, us. Every part of you carries that story. The calcium in your bones was formed in the outer layers of a star. The iron in your blood once flowed through the veins of a dying giant. The carbon that makes up your cells was born from fusion in the heart of an ancient sun, billions of years before the Earth even existed. You are, quite literally, made of starfire, matter recycled and reborn across the ages. It's a humbling thought. The same processes that light the heavens also built your body. The fusion that powers distant stars is the same chain of events that made the breath you take, the heartbeat that sustains you, and the spark of consciousness that lets you ponder your place in the cosmos. The energy that once blazed in the cores of ancient suns now flows quietly through your veins. And when those stars exploded, they didn't just create matter, they created possibility. The debris from those supernovae seeded the cosmos with diversity, making worlds like ours inevitable. Every planet, every mountain, every living thing is a byproduct of that stellar generosity. The death of one star became the beginning of countless new worlds. The fire that ended one existence became the foundation of another. So when you look at the night sky, you're not looking outward, you're looking backward, into your own origins. Every point of light is a mirror, showing you the ancestors of your atoms. You are the universe's memory made flesh, a collection of stardust still burning softly with the echo of the explosions that forged you. And in the grand silence of space, where stars are born and die in endless rhythm, there is a quiet continuity. The same fire that gave birth to you will one day return you to the stars again. Nothing is ever lost, only transformed. You are not apart from the cosmos, you are its continuation, the living flame of its eternal story. You were born from fire, shaped by gravity, refined by time, and someday, the atoms that make you will return to the sky, to burn once more in a star's heart. The fire that forged you will forge again. Without these four forces, there would be no time, no space, no stars, no you. Each is a guardian, keeping the universe from dissolving into entropy. In the grand cathedral of existence, four invisible pillars hold everything upright: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. They are the quiet custodians of reality, unseen yet unyielding, preserving the fragile balance between order and chaos. Without them, the cosmos would crumble into formless energy, an endless sea of nothingness. But together, they build, shape, and sustain everything we know. Each force plays its role in the cosmic harmony. Gravity gives structure, binding galaxies, stars, and planets in graceful orbits. It is the architect, drawing matter together, giving the universe its shape and rhythm. Electromagnetism brings texture and interaction. It is the reason atoms cling, light shines, and electricity dances through your nerves. It connects the physical with the perceptible, giving form to sensation and energy to thought. The strong nuclear force works at the smallest scales, binding protons and neutrons into the cores of atoms, ensuring matter has something to stand on. Without it, every atom would fall apart, every molecule would dissolve, and the universe would be reduced to a ghostly haze of unbound particles. The weak nuclear force, subtle yet essential, makes change possible. It transforms one particle into another, powers the sun, and drives the flow of time through decay and renewal. Together, these four forces are not just physical, they are existential. They define how the universe moves, transforms, and endures. If even one of them vanished, the chain of creation would break. Remove gravity, and galaxies would never form. Erase electromagnetism, and atoms would never bond. Without the weak force, stars would not shine, and life would never awaken to see the light. Yet, what makes these forces so extraordinary is not their strength, but their balance. Each operates on its own scale. Gravity across galaxies, the strong force within the tiniest nuclei, and yet they all cooperate seamlessly. They never compete, never collide. They complement one another with mathematical precision. Like four notes in a timeless chord, their harmony defines the very essence of reality. It's this balance that gives rise to time itself. The interplay between these forces allows matter to persist, energy to flow, and entropy to progress. Without them, the universe would be static, a perfect symmetry frozen in silence. But because they exist in tension, reality moves, stars burn, galaxies spin, atoms change, life thinks. And while they feel permanent, they are also ancient remnants of a deeper unity. Physicists believe that in the first moments after the Big Bang, all four forces were one, merged in perfect symmetry. As the cosmos cooled, that unity fractured. And from that broken symmetry, the universe was born. What we now call gravity, electromagnetism, and the nuclear forces are simply echoes of that original perfection, diversified into the structure of creation itself. Perhaps that is why the universe feels coherent despite its vastness. Every galaxy, every particle, every living thing is connected through these four laws. They do not just govern existence, they are existence. The stars, the atoms, and your heartbeat all follow the same choreography written at the beginning of time. These are the four pillars of forever, the constants that hold back chaos, that keep the cosmic stage from collapsing into darkness. They are the reason you can see, breathe, and think. They are the hands that built the stars, the threads that weave your very being. And so long as they endure, the universe will, too. Their balance is the promise that creation will continue, that even as stars fade and galaxies drift apart, the same forces will still whisper through the dark, holding everything together forever. Every second, the forces whisper to each other, gravity pulling, electromagnetism resisting, the nuclear forces holding and releasing. Their dialogue is what we call reality. The universe is not silent. Beneath the hum of galaxies and the flicker of light, a constant conversation unfolds, a ceaseless exchange of energy, influence, and balance among the four fundamental forces. Though we cannot hear it, this dialogue shapes everything: the rise of stars, the orbit of worlds, the stability of atoms, and even the beating of your heart. It is the most intricate conversation ever held, and it has never once paused since the dawn of time. Gravity begins the dialogue with a slow, patient pull, drawing matter together, sculpting clouds of gas into suns and galaxies. It speaks in curves and orbits, in the steady language of attraction. Electromagnetism answers in flashes of light and sparks of energy, painting the universe with color and motion. It governs the way atoms hold together, the way your neurons fire, the way starlight travels across the void. The two are opposites in tempo: gravity's whisper measured in eons, electromagnetism's tone sharp and immediate. yet they never fall out of sync. Then come the nuclear forces, their voices quieter but deeper. The strong nuclear force holds the centers of atoms together with ferocity, while the weak force allows change, decay, and rebirth. Together they manage the universe's smallest scales, ensuring that matter remains both stable and dynamic. They are the murmurs beneath reality's surface, the unseen architects of endurance and transformation. Every action in the cosmos is born from this dialogue. When a star ignites, it's gravity speaking with the nuclear forces, pressure and fusion reaching an agreement that allows light to exist. When a magnet pulls iron toward it, that's electromagnetism conversing through fields and motion. When an atom decays, the weak force takes its turn, whispering change into the cycle of matter. Each interaction is both question and response, push and pull, action and balance. It is through this endless communication that the universe remains coherent. Without it, there would be chaos, forces acting without regard for one another, unraveling the very fabric of existence. Instead, they negotiate constantly, exchanging energy in perfect equilibrium. The orbits of planets, the shimmer of light, the structure of DNA, all are outcomes of this cosmic correspondence. On every scale, the conversation continues. In galaxies, gravity and dark matter shape the dance of stars. In storms, electromagnetism crackles in bolts of lightning. In your cells, the weak force fuels the reactions that keep you alive. You are, in essence, a collection of these whispers, held together by the quiet dialogue of the cosmos. What makes this communication extraordinary is that it has no words, no intent, no consciousness, and yet it gives rise to both thought and meaning. The universe talks in forces, and through that conversation, it creates the possibility for us to listen, to observe, to wonder. You are not separate from that dialogue, you are part of it. Every atom in your body participates in it, every heartbeat echoes it, every breath continues it. The forces do not compete, they converse. The push of one is answered by the pull of another, forming the equilibrium that defines existence. Their conversation is not loud or chaotic but symphonic, each voice distinct, yet harmonized into something greater than the sum of its parts. And so, reality is not built from silence but from balance. It is the result of ceaseless communication, a story told through attraction and resistance. The universe endures not because the forces dominate one another, but because they listen. Everything you see, everything you are, is the continuation of that dialogue, the eternal conversation between the forces that hold the stars, the atoms, and all of existence together. Even in the quietest corner of the cosmos, where no star burns and no planet moves, the four forces hum beneath the void, keeping space itself from tearing apart. It's easy to imagine that silence in the universe means nothingness, that far from the stars and galaxies, there must be a perfect emptiness. But the deeper we look, the more we realize there is no true stillness, no absolute void. Even in the darkest, most desolate reaches of intergalactic space, where a single particle may drift for centuries without meeting another, the fabric of reality still trembles. The four forces never sleep. Space, it turns out, is alive with invisible energy. Quantum mechanics tells us that even in empty space, fields fluctuate. Particles pop into existence and vanish again in unimaginably short moments. A restless dance called quantum vacuum fluctuations. It's the universe's softest whisper, the faint hum beneath all silence. Gravity stretches across this emptiness, shaping it. Electromagnetism flickers through it, allowing light to cross it, and the nuclear forces, though confined to the tiniest scales, still echo through the virtual particles that appear and disappear in the void. This subtle energy is everywhere, woven into the fabric of space-time itself. Even where there are no atoms, the gravitational field curves gently, tugged by the unseen mass of distant galaxies. Photons, tiny messengers of electromagnetism, cross vast distances, lighting up worlds millions of light years apart. And within this apparent stillness lies a constant negotiation. gravity bending the fabric of reality, quantum fields resisting total collapse, the universe holding itself in delicate equilibrium. To the eye, the void seems empty. To physics, it is a storm. The nothing between galaxies teems with virtual particles, quantum ripples, and faint radiation left over from the Big Bang. Space is never truly blank. It seethes quietly, every point alive with possibility. This is the zero-point energy, the background hum that persists even when all else fades. If the universe were ever truly still, if every fluctuation, every vibration, every force ceased to act, it would not survive even a moment. It's this unseen motion that keeps the cosmos whole. The vacuum energy, though almost imperceptible, stretches space itself, driving the universe's slow, steady expansion. Gravity, ever patient, tries to pull everything back together. The two exist in constant dialogue, balancing each other across billions of light years. If gravity were stronger, the universe would collapse into itself. If the vacuum's energy were greater, galaxies would be torn apart before they could even form. But as it is, the balance holds, fragile, perfect, eternal. Even here on Earth, you live surrounded by this quiet hum. The air around you, the ground beneath you, the empty spaces between atoms, all are alive with flickering energy. Every inch of the cosmos vibrates with the same invisible pulse, the same ancient rhythm that began when time itself did. So, when you imagine the universe as vast and silent, remember, silence is never empty. Beneath every stillness is motion, beneath every void, a heartbeat. The forces that hold existence together never rest. They whisper across the dark, sustaining the balance that allows everything, stars, galaxies, and you, to simply be. Even the emptiest corners of creation are filled with this quiet devotion, this tireless hum of being. The energy beneath stillness is the universe's promise to itself, that no matter how dark, no matter how far, existence will never fade into true nothingness. Gravity may seem weak, but its influence is eternal. It connects everything with everything else, from the fall of a leaf to the birth of a galaxy. Among the four fundamental forces, gravity is the quietest, and yet it is the one that writes the grandest story. It does not spark or flash or hum with immediacy like electromagnetism. It doesn't bind the subatomic heart of matter like the nuclear forces. Instead, it moves slowly, invisibly, shaping the universe not in moments, but in eons. It is the sculptor of time itself, the hand that molds the vast from the simple. Every motion in the cosmos begins and ends with gravity. It is the reason stars form, the reason planets find orbits, the reason galaxies swirl into spirals of luminous grace. Its reach is infinite, stretching across trillions of miles, influencing everything from the path of photons to the shape of space-time itself. And yet, for all its power, it is astonishingly delicate. Between two electrons, gravity is 39 orders of magnitude weaker than electromagnetism, and yet it endures where all others fade. It cannot be shielded, cannot be stopped, cannot be turned off. What makes gravity remarkable is not its strength, but its persistence. It never relents. Every atom in your body exerts a gravitational pull on every other atom in the universe, however faint. You are, in a literal sense, connected to everything, the stars, the distant galaxies, even the unseen dust drifting between them through gravity's invisible thread. It is the universe's quiet declaration that separation is an illusion. Einstein revealed that gravity is not a force in the traditional sense, but the bending of space-time itself. Matter tells space how to curve. Space tells matter how to move. It's a cosmic dialogue written in geometry, a seamless interplay between form and motion. When a planet orbits a star, it isn't being pulled through emptiness. It's simply following the curves carved by gravity's hand. This curvature ripples outward, creating waves that travel across the universe whenever massive objects move, carrying the faint echoes of cosmic events to the edge of eternity. These gravitational waves are the heartbeat of creation, tiny distortions in space-time itself. When two black holes collide, or when neutron stars spiral together, gravity rings like a bell struck at the edge of infinity. We can now listen to these ripples, tracing the faint signatures of cataclysmic events billions of years old. Through gravity, the universe speaks across time, its stories written in the very fabric of reality. And while gravity sculpts galaxies, it also shapes the smallest details of our lives. It keeps your feet on the ground, guides rivers toward the sea, and gives weight to every motion you make. When a leaf falls from a tree, it's answering the same call that keeps the moon tethered to Earth. The same law that governs the dance of planets also governs the descent of a snowflake. Gravity unites the gentle and the grand in one seamless principle. It is, in many ways, the most human of the forces, patient, constant, and inevitable. It draws everything toward everything else, but allows distance, orbit, and flow. It reminds us that even in separation, there is connection. Even in stillness, there is attraction. In the end, gravity is the quiet pulse of the infinite, a bridge between the smallest motion and the grandest structure, between the temporary and the eternal. It does not fight for dominance, it simply is. The universe expands, stars are born and die, and still gravity endures, stitching the cosmos together, one silent curve at a time. It is the slow heartbeat of forever, the invisible architecture upon which reality rests. From the fall of a leaf to the birth of a galaxy, gravity whispers the same truth across all scales, that everything, everywhere, is connected. Every radio wave, every aurora, every flicker of a neuron is part of electromagnetism's endless dance, a reminder that even the void is alive with invisible energy. If gravity is the skeleton of the universe, electromagnetism is its heartbeat. It pulses through the fabric of existence, animating the stillness, giving color, light, and charge to the cosmos. It is the reason stars shine, magnets pull, and atoms cling. Every spark of lightning, every beam of light, every thought in your mind, each is a note in electromagnetism's infinite symphony. This force is one of nature's most expressive voices. It carries information, ignites stars, and binds the invisible to the visible. It doesn't just move through space, it defines space, giving energy a rhythm, giving matter a voice. When a charged particle moves, it creates a magnetic field. When it accelerates, it sends ripples through the vacuum, waves of pure energy we call light. Those waves can travel across billions of years and still arrive, unchanged, to strike your eyes and awaken sight. Light is electromagnetism in motion, an eternal traveler that never slows, never tires. From the soft glow of a candle to the blinding brilliance of a quasar, it is all the same thing, oscillations of electric and magnetic fields locked in a perfect dance. These oscillations are the universe's way of communicating with itself, allowing energy and information to move from one corner of reality to another. On the smallest scale, electromagnetism is the sculptor of atoms. It binds electrons to nuclei, determines how molecules form, and governs the chemistry of life. Without it, there would be no solidity, no color, no warmth, nothing to touch, nothing to feel. The very concept of matter depends on the subtle conversation between charged particles, held in place by this unseen force. On the grand scale, it paints the sky. When charged particles from the sun meet Earth's magnetic field, they spiral along invisible lines, colliding with our atmosphere to create curtains of green and violet light. The auroras, those same magnetic fields protect us, deflecting the solar wind that would otherwise strip away our air and water. What looks like beauty is, in truth, survival made visible. And within you, electromagnetism becomes life itself. Every thought, every heartbeat, every breath is carried by tiny electrical impulses, currents flowing through the neurons of your brain and the muscles of your heart. When you move your hand, it is electromagnetism that contracts your muscles. When you remember something, It is electromagnetism that lets your neurons whisper to one another across synapses. The same force that lights the stars also lights your mind. Electromagnetism connects the cosmic and the personal, the infinite and the intimate. It links the dance of galaxies with the flicker of human consciousness. The radio waves that carry a message across oceans, the sunlight that warms a distant world, the pulse that beats in your chest, all are threads in the same glowing web. Even in the vast emptiness between galaxies, the electromagnetic field hums faintly, alive with background radiation, the leftover whisper of the Big Bang itself. The universe is never truly dark, never truly still. Everywhere, the electric heart continues to beat, sending waves of energy rippling through eternity. Perhaps that's why electromagnetism feels so alive, because it is life's very rhythm. It is the breath of the stars, the spark of the mind, the current that flows through the veins of the cosmos. It binds light to motion, energy to meaning, matter to memory. So when you see a flash of lightning across the sky, when you feel warmth on your skin, or when you close your eyes and listen to the quiet hum of existence, remember, you are feeling the pulse of the universe itself. You are alive within the electric heart of the cosmos. At the quantum scale, particles appear and vanish in moments, balanced by the push and pull of the strong and weak forces. Beneath the calm surface of existence lies a battlefield so small that it defies comprehension. A realm where creation and destruction happen constantly, where empty space churns with unseen motion. To the naked eye, the universe may appear still, but at the smallest scales, it's a ceaseless storm of energy and transformation. This is the quantum realm, the stage upon which the strong and weak nuclear forces perform their most intricate and essential work. Here, protons and neutrons are not solid spheres, but restless gatherings of smaller entities, quarks, bound together by the strong force. Between them, particles called gluons race endlessly, carrying the binding energy that keeps matter intact. The strong force is relentless. It does not weaken with distance but grows stronger, ensuring that quarks can never be separated. In this microscopic world, confinement is law, an eternal tension that holds the fabric of matter together. And yet, even this seeming stability hides constant motion. Gluons themselves flicker in and out of existence, their fields vibrating with intensity. Around them, virtual particles bubble up from the vacuum, fleeting pairs of matter and antimatter that appear, interact, and vanish before they can be observed. The vacuum, far from being empty, is alive, a field of infinite potential, trembling with possibilities that never rest. The weak force moves quietly through this chaos, changing one kind of particle into another. It is the agent of decay and rebirth, turning protons into neutrons, neutrons into protons, shaping the alchemy that fuels stars and determines the lifespans of atoms. It's this subtle transformation that keeps the universe from stagnating, ensuring that matter evolves, decays, and renews itself. Imagine it. Inside every atom, trillions of interactions occur every second. Forces pulling, pushing, transforming, binding, and releasing. Nothing is still. Even when you rest your hand on a table, its atoms vibrate with energy. Their nuclei alive with movement, their electrons flickering in probability clouds. What seems solid is actually a blur of motion slowed only by scale. This battlefield is perfectly balanced. The strong force prevents the atom's core from collapsing, while the weak force allows it to change and adapt. Without one, the other would lead to ruin. Too much strength and nothing would evolve. Too much decay and nothing would last. The universe's persistence depends on this invisible war, fought in every nucleus of every atom, in every second of time. It's strange to think that the foundation of everything we know is built upon conflict. But this is not a war of destruction. It's a war of creation. The struggle between the strong and weak forces produces not chaos, but structure. It's through their constant push and pull that atoms gain stability, that stars can shine, that life can exist at all. Even in the quiet of the vacuum, the echoes of this war continue. The so-called emptiness of space teems with virtual particles flickering in and out of being, exchanging energy in ways that shape the universe's expansion. The battlefield never ends. It simply grows quieter as you move away from matter, but never silent. And perhaps that's the most astonishing truth of all, that even in nothingness, the universe is never still. Every point in space, every moment in time, is alive with invisible motion, with forces at play that never rest. The quantum world may be unseen, but it is the foundation upon which reality stands. Beneath stillness, there is struggle. Beneath silence, there is sound. Beneath nothing, there is everything. If the strong force were 2% weaker, atoms could not exist. If gravity was slightly stronger, the universe would have collapsed seconds after it began. The universe gives the illusion of strength, galaxies spinning, stars burning, matter enduring for billions of years. But underneath that grandeur lies a terrifying fragility. Everything, from the birth of light to the beating of your heart, depends on an exquisite balance between the four fundamental forces. A change so small it could fit in the margin of an equation would have erased all possibility of existence. The strong nuclear force binds the cores of atoms together with unimaginable intensity. But if it were just a little weaker, 2% less, the protons and neutrons inside nuclei would no longer hold. Atoms would disintegrate into a soup of unbound particles. Matter itself would fall apart. Yet, if it were only slightly stronger, fusion in stars would happen too easily. Hydrogen would burn too fast, and the stars would exhaust themselves long before life had the chance to begin. Gravity, too, must walk a razor's edge. It is the sculptor of the cosmos, but also its executioner, if unchecked. If gravity were only a fraction stronger, the early universe would have collapsed before galaxies could form. If weaker, the expansion after the Big Bang would have scattered matter too quickly, leaving nothing to coalesce into stars or planets. The entire story of creation depends on this perfect equilibrium, an invisible thread stretched across infinity. Electromagnetism holds its own crucial role in this balancing act. The charge of the electron, its mass, and the strength of its attraction to protons must align perfectly. Change that balance, and chemistry itself fails. No molecules, no reactions, no complexity, just a barren expanse of lifeless matter. Even the light we see, the heat we feel, the bonds that make DNA possible, all rely on the unyielding precision of this one force. And the weak nuclear force, so often overlooked, is no less vital. It governs the processes that allow stars to shine steadily instead of erupting in uncontrolled fury. It regulates nuclear decay, shaping the abundance of elements across the universe. If it were too weak, the stars would go cold, too strong, and they'd explode before planets could form. The difference between darkness and life is written in its quiet restraint. It's almost unbearable to consider how close the universe came to not existing at all. The forces that define everything could have easily fallen out of tune, and we would never have been here to notice. And yet, they didn't. Across 13.8 billion years, through explosions and collisions and the slow cooling of space, that balance held. Every atom, every orbit, every breath is proof of a precision so exact it feels deliberate. Scientists call this fine-tuning. Some see it as coincidence, a natural outcome of physical laws we don't yet understand. Others see design, or inevitability, or something deeper than chance. But no matter the interpretation, the fact remains. The constants of nature are balanced so delicately that even a whisper of change would erase the stars. You live suspended in this fragile miracle. Every second, the forces continue their silent work, gravity holding you to Earth, electromagnetism keeping your atoms intact, the strong and weak forces maintaining the very nuclei of your cells. It is a miracle so precise, so improbable, that it could be mistaken for perfection. And perhaps that's what makes existence so precious. The universe doesn't need to be here, but it is. Balanced on the knife edge between chaos and collapse, it endures. Fragile, finite, miraculous. Every moment you experience, every heartbeat, every thought is a celebration of that balance. The cosmos could have chosen silence, and instead, it chose you. Some physicists wonder, do these forces exist independently, or only because we do? Perhaps the universe is a self-aware equation, dreaming itself into being. It's an unsettling and beautiful possibility that reality, in all its vastness, might not exist out there at all, but only within the act of perception itself. That the four forces, the constants, the laws that give rise to galaxies and atoms, might depend on consciousness to be real. Some of the brightest minds in physics have quietly asked this question. What if the universe is not a place, but a thought? Quantum mechanics first cracked open this mystery. In the subatomic world, particles do not have definite positions or states until they are observed. They exist as clouds of probability, potential realities waiting to be measured. When we look, they collapse into one outcome, into something real. Does that mean observation creates reality, or does it simply reveal what was already there? If the universe is governed by probabilities, then reality itself may be participatory, woven from the interplay between the cosmos and the act of noticing it. In this view, the four fundamental forces are not mere mechanisms but expressions of awareness. Gravity as the memory of connection, electromagnetism as the pulse of experience, the strong force as the will to hold, and the weak as the capacity to change. Together, they become not just physical laws but principles of perception itself. Some theories, like the anthropic principle, suggest that the universe has the properties it does because we are here to observe it, that our existence, improbable though it is, may actually shape the laws that allow it. It's a philosophical feedback loop. Life arising because the universe permits it, and the universe existing because life observes it. The observer and the observed, the dreamer and the dream, forever intertwined. If that sounds poetic, it's because it is. The equations that describe reality, Einstein's relativity, Maxwell's electromagnetism, Schrödinger's wave function, are not just mathematical, they are statements of relationship. They describe how things interact, how one influences another. In a sense, they describe how the universe thinks. Perhaps, then, existence is not a static thing, but an ongoing act of awareness, a self-sustaining thought so vast it manifests as space and time. A thought that curves into galaxies, ignites into stars, crystallizes into atoms, and eventually awakens within itself as consciousness. You are not separate from this process. You are part of it, the universe recognizing itself, briefly, through your eyes. Every observation, every act of wonder, is the cosmos reflecting upon its own complexity. When you gaze at the stars, you are not merely looking outward, you are looking inward, at the mind of the universe contemplating its own creation. Maybe that's what the four forces truly are, not just interactions of matter and energy, but the structural language of awareness itself. They are the syntax of the universe's thought, the rules by which it imagines form, motion, and life. And if that's true, then everything, every atom, every galaxy, every consciousness, is part of a single, ongoing equation, dreaming itself into reality. A universe that does not just exist, but knows it exists. Perhaps we are not passengers within the cosmos, but moments within its mind. Thoughts in an infinite dream, sparks of awareness in an endless act of becoming. The universe may not need a thinker because it is the thought, alive, curious, and forever unfolding itself through us. The universe has lasted nearly 14 billion years because its forces maintain harmony. Too much chaos and everything flies apart. Too much order and nothing ever changes. Every second, from the smallest atom to the largest cluster of galaxies, the cosmos performs a balancing act so precise it defies imagination. It is not static, nor is it chaotic. It moves between the two, suspended in a state of perfect tension. That balance, that fragile harmony among the four fundamental forces, is the reason the universe endures. Gravity pulls everything together. Electromagnetism pushes and binds. The strong nuclear force holds the atomic heart firm, while the weak force ensures nothing remains unchanged forever. These forces do not compete. They converse. Their interplay, creating a rhythm that defines existence itself. Each checks the other, keeping the universe poised between expansion and collapse, between permanence and transformation. If gravity were even slightly stronger, the universe would have imploded long ago, collapsing into a sea of black holes. If weaker, matter would have scattered too fast for stars to ever form. If the strong nuclear force tightened its grip, no atoms could fuse. If loosened, no atoms could hold. And if the weak force ceased to act, the slow alchemy of the stars, the conversion of elements that makes life possible, would grind to a halt. Everything, from light to life, relies on this exactness. It is as though the universe itself understands balance, not through intention, but through the immutable precision of its laws. Too much order, and time would freeze in perfect symmetry, a cosmos of unchanging silence. Too much chaos, and there would be no time at all, only motion without meaning, expansion without structure. Between these two extremes lies creation, the narrow band of possibility where stars burn, atoms hold, and life can think about the miracle of its own existence. You can see this equilibrium everywhere, in the gentle tug between Earth and the Moon that creates the tides, in the way a candle burns, consuming and creating destruction and beauty in one act, in the cycle of life and death, birth and decay, where the universe continuously recycles its matter and energy, never gaining or losing, only transforming. Even the expansion of the universe is a form of balance, a dialogue between gravity, which pulls inward, and dark energy, which pushes outward. For billions of years, these two forces have danced in near-perfect opposition, sculpting a cosmos that neither collapses nor dissipates. It is the grandest equilibrium of all, written across the geometry of space and time. This harmony is not static, it's dynamic, alive, sustained through change. It's the reason galaxies can rotate for billions of years without falling apart, why atoms can endure for eons yet still allow transformation, why your body is a balance of decay and renewal, of entropy and order. You are a participant in the same equilibrium that governs the stars. Perhaps that's why existence feels both fleeting and infinite, because we live at the edge between stillness and motion, between chaos and calm. The universe itself is neither one nor the other. It is both, eternally. The four forces, in their constant interplay, teach us something profound. Balance is not the absence of change, but the harmony of opposites. The cosmos survives not by perfection, but by dynamic tension. It breathes, expands, and evolves in the space between order and disorder, the eternal equilibrium that allows it to exist at all. And as long as that harmony endures, so will everything within it. Stars will burn, worlds will spin, atoms will hum, and life will continue to rise and fall in rhythm with the cosmic balance forever. Each force contributes a note to the cosmic song, gravity the bass, electromagnetism the melody, the nuclear forces the rhythm. Together, they perform the music of everything. If you could translate reality into sound, the universe would not be a single tone, it would be a symphony. Every particle, every wave, every motion would hum with resonance. The galaxies, the stars, the atoms within your blood, they are all instruments in an orchestra that has been performing since time began. Its composition is vast beyond measure, and yet perfectly in tune. Gravity plays the bass line, the deep, slow vibration that gives the universe its structure. It sets the tempo of motion, the beat that guides galaxies as they spin in graceful spirals. It is steady, patient, and unyielding, the rhythm of time itself. Through gravity, the cosmos has a pulse, an eternal downbeat that holds the music together. Electromagnetism carries the melody. It's the song of light, the shimmer of color, the hum of energy that moves through everything. It gives the universe its texture and tone, its glow and warmth. Every photon that travels from a distant star, every spark that leaps from a storm cloud, every heartbeat in your chest, all are notes in electromagnetism's infinite refrain. Its melody is the one we can see, feel, and live within. Then there are the nuclear forces, the strong and the weak, the drummers of creation. The strong force keeps the rhythm steady, binding atoms in perfect tempo, ensuring that matter remains coherent, stable, and enduring. The weak force, subtler and more intricate, provides syncopation, the gentle irregularities, the moments of change, decay, and renewal that keep the symphony alive. Without the weak force's quiet improvisations, the music would never evolve. Together, these four forces form a harmony so complete that everything we know, light, matter, time, and thought, emerges from their interplay. The universe is not chaos, nor is it rigid order. It is a living composition, one where each note supports the next, where contrast becomes beauty, and where silence gives meaning to sound. And within that vast orchestration, every atom in your body is part of the performance. The protons and electrons that build your cells move in rhythm with the same forces that sculpt the stars. The photons striking your eyes tonight began their journey eons ago in stellar cores, carried by electromagnetism's melody, guided by gravity's tempo. You are not merely listening to the cosmic symphony. You are one of its notes, resonating softly within the grand design. If you could stand outside of time and listen to it all, the deep pull of gravity, the luminous chords of electromagnetism, the pulsing beat of the nuclear forces, you would hear a song older than the stars, one still being written with every heartbeat, every supernova, every new world born from dust. It's a song of opposites, tension and release, order and freedom, silence and sound. The universe does not repeat, it improvises, finding balance within complexity, harmony within motion. Every second is another measure, another phrase in an endless composition that began in the instant of creation and will echo until the last atom fades. So when you look at the stars, or listen to the rain, or feel the quiet rhythm of your own breathing, know that you are hearing the same music. The cosmos is not a machine, it's a masterpiece. The four forces are not mechanics, they are musicians. And together, they perform the greatest symphony ever written, the music of existence itself. The more we learn, the clearer it becomes. Existence is not inevitable, it's precise. We live in a universe that balances on the edge of impossible perfection. Every constant, every force, every particle behaves exactly as it must for reality to exist. It's as if the cosmos were tuned to a frequency so narrow that even the faintest shift would plunge it into silence. From the smallest quantum vibration to the vast curve of space-time, everything moves in perfect correspondence, each equation whispering the same secret: the universe should not exist this beautifully, and yet it does. The four forces, gravity, electromagnetism, the strong, and the weak, are not just physical laws, they are the fine threads that keep existence from unraveling. Gravity holds galaxies in their slow dance. The strong force glues atomic hearts together. Electromagnetism binds atoms into molecules, shaping matter into form. The weak force allows transformation, decay, and rebirth. Each acts independently, yet all depend on one another. Too much of one, too little of another, and the entire structure collapses. Consider this: if the strength of gravity had differed by 1 part in 10 to the 60, the universe would have torn itself apart before stars could ignite, or collapsed back into itself before atoms could form. If the electromagnetic force were even slightly stronger, electrons would cling too tightly to their nuclei, and chemistry would fail. If weaker, atoms would drift apart, unable to bond. And if the balance between matter and antimatter after the Big Bang had been perfect, just one part in a billion more symmetrical, nothing would remain but empty radiation. It's a staggering thought. Every breath you take, every beam of starlight, every second that passes is possible only because of this razor-thin balance, a cosmic choreography maintained since the dawn of time. The universe doesn't simply exist, it persists, walking forever on the edge of impossibility. Some see this precision as chance, a cosmic lottery we happen to win. Others sense something deeper, as if the laws of nature themselves are self-aware, adjusting in harmony to sustain creation. Whether by accident or by design, the result is the same, a universe tuned so precisely that it seems to know what it's doing. This perfection, however, is fragile. It could all unravel with the slightest change, a shift in the constants, a decay in the balance, a new law emerging from the quantum depths. And yet, despite its fragility, it endures. Through entropy and chaos, through billions of years of expansion and collision, the harmony holds. Perhaps perfection was never meant to be eternal. Perhaps it's not stability that allows the universe to exist, but tension, the constant negotiation between balance and decay. The universe is not static, it's alive, in motion, in conversation with itself. Its perfection is not the absence of flaws, but the resilience to keep evolving in spite of them. Look around you. Everything you see, the stars, the oceans, the breath in your lungs, is the result of an exquisite balance that began 13.8 billion years ago and has never once failed. You are built from that precision, sustained by it, and one day you'll return to it. We live not in a random universe, but in a deliberate one, a reality so finely tuned that it feels less like an accident and more like a miracle of mathematics, of motion, of meaning. The cosmos may not be eternal, but as long as this fragile perfection endures, it will continue to sing, a harmony between chaos and order, existence and void, forever poised on the edge of the impossible. Why do these forces exist at all? Why this balance and not another? After all the equations, after all the theories and discoveries, we arrive at a silence, a question that the universe itself seems to whisper but never answer. Why this set of laws? Why these constants, these forces tuned so perfectly that they give rise to stars, atoms, and life? It is the oldest question, and perhaps the final one. Science can tell us how the universe works, how gravity curves space, how electromagnetism animates energy, how nuclear forces sculpt matter from chaos. But beneath all that understanding lies a deeper mystery. Why the universe chose to work this way, and not another? Some physicists believe the answer lies in the multiverse, a vast ensemble of possible realities, each governed by its own laws and constants. In most, the forces are too strong or too weak for stars or atoms to exist. In a few rare universes, the balance is right. And in one of them, we opened our eyes and began to wonder. By that reasoning, we are the inevitable witnesses of the only universe capable of having witnesses at all. Others believe the answer is even simpler and infinitely more profound, that the universe is self-explanatory, that its balance is not random but necessary, that the laws of physics exist because they are the only ones that can exist. In that view, the four forces are not arbitrary. They are the expression of something fundamental, timeless, and complete. And still others look inward, sensing that the question itself may be the answer, that the universe asks through us, that consciousness is not an accident within creation, but a continuation of it. Perhaps the forces exist because they lead to life, and life exists to reflect on them. In that sense, the universe did not simply happen, it awakened. There is a quiet humility in that idea, that all of this, the galaxies, the atoms, the equations, the minds, exists so that the cosmos can observe itself, if only for a moment, Every question we ask is the universe thinking about its own existence, peering back into its origins through our eyes. Maybe we will never find the ultimate answer. Maybe it lies beyond the reach of observation, beyond the veil of space-time itself. But perhaps that's what keeps the universe alive. The mystery, the incompleteness, the eternal curiosity written into its very laws. The four forces hold the cosmos together, but questions hold meaning together. They are the fifth force, the gravity of thought, the reason we reach outward at all. And so, as we gaze into the night and wonder why there is something instead of nothing, we become the continuation of the very forces we seek to understand. The universe dreams, and through us, it wonders. In the end, perhaps that is all the answer we need. Not certainty, but awareness. Not perfection, but the act of asking itself. Because the moment we ask why, the universe, for a brief and brilliant instant, knows that it exists. When you close your eyes tonight, remember, every breath you take, every heartbeat, every drifting star, all are held together by the same four invisible threads. Gravity keeps you grounded. Electromagnetism lets your heart spark with life. The strong force binds your atoms. The weak one changes them, allowing stars to shine and time to move forward. These are not distant cosmic laws. They are the quiet reasons you exist. The universe is not chaos. It is balance. Every galaxy, every cell, every whisper of light depends on this perfect harmony that has lasted for nearly 14 billion years. The cosmos did not have to be stable, yet it is. It did not have to create life, yet here you are, born from stardust, held together by the same forces that hold the heavens. So as you drift into sleep, feel the weight of gravity as comfort, the hum of electromagnetism as warmth, the pulse of nuclear forces as the rhythm of existence itself. You are part of the same physics that builds galaxies, and that is no small miracle. Rest easy beneath the fabric of the cosmos. You are safe inside the balance that keeps everything from falling apart.